Yeah, hi everyone. So we have been studying about analytic function and entire function. We started the introduction in the last lecture. First we studied about limit, continuity, differentiability. Then we started analytic function and entire function. So we have seen the basic introduction. All these things we have seen that what all are the examples of entire function, what is the meaning of entire function, what is the meaning of analytic function, and everything we have seen. Now we need to solve this question. It is very important. So treat this question as some properties. These are the properties of analytic function. So what is given? F of z equals to u plus iota v is given. It is analytic in domain D. What is the meaning of this? Analytic in domain D. So let's just say I am defining my domain as mod of z equals to 1. What does that mean? Or I should define that domain as mod of z less than equals to 1. What does that mean? That means, sir, this circle that you have made, no, this will represent a circle, or you would say this will represent a disk. So inside this circle, at all the points, the function will be analytic. This will represent a disk, no? So inside this circle, whatever the points are available, no, at all the points the function is analytic. If I make the circle like z minus 1 less than equals to 1, that means inside this circle at all the points the function will be analytic. If I make the domain somewhat looking like this is my domain. So inside this particular structure, whatever the points are available, no, everywhere the function will be analytic. This is the meaning of analytic in domain D. So whatever the domain that I have decided, in that domain the function will be analytic. Understandable? So just the language, nothing else. Then which of the following statement is true? So you already know, sir, what is the property of analytic function. So first of all, what you will do is that you will assume example f of z equals to z square. Is it analytic? Yes, sir, it is an entire function actually. Yes, it is analytic everywhere. So you assume this example and solve all these properties, solve all the options with respect to this example. What you will do is that you will convert it into x comma y. That would be x square minus y square plus iota 2xy. You will, this is your u, this is your v. You calculate ux, vy, vx, uy, everything you calculate and verify all the properties. So this is your homework. That means you will do it on your own. But I will teach you the mathematics here. Okay. Now we are going to solve with respect to mathematics. We are not going to solve with respect to example. So what is given? Given is that our function f of z is u plus iota v and it is analytic. So we already know that, sir, if it is analytic, then we will calculate ux, we will calculate ui, we will calculate vx, we will calculate vy. Then I know that, sir, cross multiplication main diagonal will be as it is, ux will be equals to, एक तो ये u लिखने की आदत ना, like we have to build the habit of u writing like this. Ux would be equals to vy and vx will be equals to minus ui. This we already know. Next we need to talk about the Laplacian. Do you remember the Laplacian operator? This was your option A. Do you remember Laplacian operator? Do you remember the meaning of this? Del square. So this operator was nothing but del square by del x square plus del square by del y square plus del square by del z square. Here only x and y we need to treat. X and y only we need to treat because u will be a function of x comma y. This will be a function of u will be a function of x comma y and v will also be a function of x comma y only. So both are function of x comma y. That means this will not be helpful for us. So what we need to treat? We need to treat del square u. What is the meaning of del square u? So meaning of del square u will be nothing but del by del x square u, del square by del y square u. So what is your del square by del x square u? That means del by del x, del u by del x. Say yes or no? You need to partially differentiate u twice. You need to partially differentiate u twice with respect to y. You need to partially differentiate u twice with respect to y. Say yes or no? Now let me know what is ux. Let me know what is ux. Ux is nothing but, sir, ux is equivalent to vy. So this is your del by del x vy. Say yes or no? Sir, del u by del x is equals to del v by del y. So can I write down in this way? Say yes or no? Plus del by del y. Let me know what is your del u by del y. What is your ui? Del u by del y. That means what is your ui? Sir, ui is equals to minus vx. Ui equals to minus vx. So what you can do is that you can take this minus sign outside. What you are getting? First you partially differentiate v with respect to y and then you partially differentiate it with respect to x. First you partially differentiate with respect to y, then you partially differentiate with respect to x, minus you partially differentiate v first with respect to x and then with respect to y. Aren't both of them same? I told you, no. that if there is a function f, first I partially differentiate it with respect to x, then with respect to y, or if I partially differentiate it with respect to y and then with respect to x, both will give you the same result. Take any example you can take up. First you partially differentiate with respect to x, then with respect to y, or first you partially differentiate with respect to y and then with respect to x, both will give you the same results. No, it is pretty obvious, right? So aren't both of them same? They are same, that means this will come out to be 0. So what you are getting, del square u is coming out to be 0, and similarly del square v will also come out to be 0. Similarly both of them will come out to be 0. That's it. So second option is also proven. So first is also proven, second is also proven. Now do you remember one thing, that if del square f comes out to be 0, what we used to say, that f is a harmonic function. Now what we have seen, the del square u is coming out to be 0, del square v is coming out to be 0. Then what we can say, u and v are harmonic functions. Now what I do, I give you a random u. I am giving you, a random function I am giving you. It is a function of x comma y, and I am giving you a random v as well, which is a function of x comma y, and I tell you that both are harmonic functions. That means I am telling you that del square u will also come out to be 0 and del square v will also come out to be 0. Now you let me know, is this enough to say that if I make a function f of z, which is u plus iota v, it will be analytic for sure? Is it enough to say? Again listen to my problem statement carefully, that I am giving you a random u, I am giving you a random v as well. U and v I have given. I have framed them in a way that del square u is coming out to be 0, del square v is also coming out to be 0. Now what I am doing, I am taking those u and v and I am making a function f of z, which is u plus iota v. Now I am asking you, are you sure that f of z will be analytic? No. Because what is the property of analytic function? The property of analytic function is that ux should be equals to vy and vx should be equals to minus ui. This is the property, no? Look, I can take any random function, and make both of the Laplacian equals to 0. But will it make sure that this guy and this guy will be equal? No, right? So what does that mean? That means if f of z is analytic, then this is true. But if this is true, then f of z will be analytic. That is not sure. Again, let me repeat the statement, that if f of z is analytic, no, then this is true. But if this is true, that doesn't mean that f of z will be analytic. Are you able to understand this point or not? Understandable? So this is the meaning. This I have framed as a question. Okay. Later on, I have framed it as a question here. Here I have framed it as a question, that del square u equals to 0 and del square v equals to 0 is given. Nothing else is given. I am not saying that this is an analytic function. So can you say it will be analytic? No, it may be analytic, and it will be analytic only if this condition is satisfied. Understandable? So this is what I am saying, that these statements are given. Yes, they are harmonic function. So this statement plus this statement, ux equals to vy and vx equals to minus ui. These two combined will make sure that will make sure that f of z is analytic. F of z is analytic. Say yes or no. And if these two combined property we follow, if there is a function u and v which is following both of the properties, then we will say that u and v are harmonic conjugate of each other. What is the meaning of harmonic conjugate of each other? That means, sir, it should follow the option A as well and it should follow the option B as well. That means if you are choosing your function u and v in a manner that ux equals to vy and ui equals to minus vx, along with that their Laplacians are also 0, then you will say that u and v are harmonic conjugate of each other. What is the meaning of being harmonic conjugate of each other? That means, sir, they should be harmonic function. Harmonic function means their Laplacian should be 0. Along with that, sir, ux equals to vy and ui equals to minus vx. So if both of the properties are being followed, then we will call it harmonic conjugate. If only one property is being followed, then we will say they are harmonic functions. Two different things are there: harmonic functions and harmonic conjugates. So they will be known as harmonic conjugates if they are harmonic functions as well. Along with that, they are following this property as well. Let me know one thing, if they are following this property, then it is sure no, they will be harmonic function as well. If your u and v are following this property, if u and v are following this particular property, then using this property only we have got to know that they are harmonic as well. So here the bottom line is that if only this particular thing is given, del square u equals to del square v equals to 0, then you cannot say your function will be analytic. You have to check this condition. This is the necessary condition. This is the necessary condition. Necessary condition for the function to be analytic. Necessary condition for analytic. This condition is necessary. Only by Laplacian equals to 0 you cannot say they will be analytic. But if it is given that function is analytic, then for sure Laplacian will be equals to 0. Understandable? Now let's find out the gradient of u and gradient of v. What we are supposed to find out? C option we are taking gradient of u. Basically they are asking del u and del v. This is something that they are asking. Okay, so you know that sir, u is a function of x comma y. It is a scalar function. It is a scalar function. And similarly v is also a function of x comma y. It is also a scalar function. So can you calculate their gradient? Absolutely. What will be the gradient? What is the meaning of gradient? So the meaning of gradient is del by del x u I cap, del by del y u j cap, right? And we are doing the dot product, no? So what we are doing? We are doing the dot product. So dot product with del by del x v I cap plus del by del y v j cap. Understandable? Now what you will be getting? Partial differentiation of u with respect to x I cap plus partial differentiation of u with respect to y j cap, dot product with partial differentiation of v with respect to x I cap plus partial differentiation of v with respect to y j cap would be equals to ux I cap will be multiplied with vx I cap. So you are getting ux vx plus uy vy, ux vx plus uy vy, ux vx plus uy vy. So what this could be treated as? Now you know that what is the property, that sir ux should be equals to vy and sir uy should be equals to minus vx. This is the property of an analytic function, no? This is the property. Ux should be equals to vy and uy should be equals to minus vx. So this we can put here. Keep in place of ux you put vy vx. In place of uy you put minus vx vy. What answer you are getting? vy vx minus vx vy. Answer is 0. So this particular thing is coming out to be 0 only. So yes or no. So which two options we have proved? This option also we have proved and this option also we have proved. That's why ux vx plus uy vy will be 0 only, and gradient of u dot product, not dot product, yeah, gradient of u dot product with gradient of v will be 0 only. So what we have seen, this is very simple, no? This you should have done on your own. You know how to calculate the gradient ux vx uy vy, then simply put ux value as vy and uy value as vx, uy value as minus vx. You are seeing that answer is coming out to be 0. So what you have seen here, that's our gradient of u dot product with gradient of v is coming out to be 0. Now let's just say I make a surface. I make a surface and the surface is, sir, whatever the function of u of x comma y was there, no, I equate it to c1. And the other function which was v of x comma y, I equate it to c2. So two surfaces I have made. Now if I want to find out their perpendicular vectors, how will I find out the perpendicular vectors? What I would do, I would make the function phi1 which will be u of x comma y minus c1, and I will make the function phi2 which will be v of x comma y minus c2. Now if I calculate gradient of phi1, what it will come out to be? Sir, it will be gradient of u of x comma y minus c1 would be equals to gradient of u of x comma y minus gradient of c1. It is a constant value, no? C1 could be 3, 4, 5. It is a constant value, so this will be 0 only. So you already know this thing, that gradient of phi1 would be equals to gradient of u of x comma y as well. Like basically this constant will not change anything. So both will be same. And similarly, gradient of phi 2 will also be equals to the gradient of v of x comma y as well. What this would represent? What both of these things would represent? They would represent the perpendicular vectors, perpendicular vectors of their respective surfaces. And if I say two vectors, vector A dot vector B is 0, what does that mean? That means they are perpendicular to each other. That means they are perpendicular to each other. So similarly, here what I would see, that del phi 1 dot product with del phi 2 will come out to be 0. So from here what you will see, that means they are perpendicular to each other. That means if I call it curve C1, if I call it curve C1, and if I call this as curve C2, then the perpendicular vectors of C1 and C2 are orthogonal to each other. That means your curve C1 is perpendicular to curve C2, or I should say your curve 1, I will call it curve 1 and curve 2. I will call it curve 1 and curve 2. Then I should say that curve 1 is perpendicular to curve 2. There you go. This is the conclusion that we have made. Say yes or no. Is it completely understandable or not? Sir, their gradient, the dot product of their gradient is coming out to be 0. That means, sir, if I make a level surface, I should not say curve, I should say surface. Curve also we can say, but better word would be surface. Sorry guys, again and again I am changing. I should say surface here. Surface 1 and surface 2. Okay, so here surface 1 and surface 2. Surface 1 and surface 2. So surface 1 and surface 2 are perpendicular to each other. Is that understandable to you or not? Okay, so this also we have proved that they will frame a family of orthogonal curves. Very important in MCQs. This is something that would be asked, that if f of z is analytic, then which of the following statements are true? In that manner it would be asked. They would ask first of all about the Laplacian, that del square u would be equals to del square v would be equals to 0. Second, they can ask about their gradient. They will frame the gradient, like they will be perpendicular to each other. They will frame a orthogonal family of curves, and along with that they will ask about this harmonic conjugate as well. So this is how they can frame a MCQ question in the GATE examination. Very soon this kind of question is coming in your examination. I'm telling you, it is very important. I hope everything we have proved and everything is completely clear to you. Last point is also clear, that sir, if their gradient is coming out to be, the dot product of their gradient is coming out to be 0, that means sir, surely they are making orthogonal vectors. If their perpendicular vectors are orthogonal, that means they are having 90 degree of angle between them. 90 degree of angle, what does that mean? That means they are orthogonal to each other. That's it. Okay, very important. And this question also we have seen, that if only one thing is given, that Laplacian of u is 0, Laplacian of v is 0, that is not enough to call a function analytic. For the function to be analytic, this condition has to be satisfied. This is the necessary condition. The function may be analytic, the function would be analytic if this condition is satisfied. Understandable? Okay. Let's see a new theorem, which is Milne-Thomson theorem. What is the name of this theorem? Milne-Thomson theorem. So in short form, I will always say what MT said. MT. I will use the word MT. So what MT said. If your f of z is analytic, better I should say, if f of z is entire function. If your f of z is entire function, then what they said? They said that x is z and y is 0. This is what they said. In a crude way, I am telling you that x is z and y is 0. You can replace x with z, z with x, and you can replace y with 0. What does that mean? Now this f of z is given. And it is given that it is an entire function. You can check as well. On your own, you can check. How you can check? You can check by calculating ux, that will come out to be 2x. Then you can calculate uy, that will come out to be minus 2y. Then you can calculate vx, that will be 2y, and you can calculate vy, that would be 2x. You can say that yes sir, it is nothing but entire function only. Yes sir, it is entire function only. Now if it is entire function, no, now they are asking what is f of z in terms of z. Do you already know about this? Sir, yes sir, we have seen this example again and again, that if your f of z is z square, then it would come out to be as x square minus y square plus iota 2xy. Sir, this example we have seen at least 10 times, so now I remember it, sir. Yes, you have already seen it. What MT said, that if your f of z is entire, no, very very important, if it is an entire function, no, then what you can do, you need to write down this in terms of z. So what you can do, in place of x you can put z, and in place of y you can put 0. X is z, y is 0. In place of x you can put z, and in place of y you can put 0. What answer are you getting? So z square minus 0 square will be z square only, plus iota 2z into 0 will be 0 only. What answer you are getting? F of z equals to z square. There you go. That means whenever you get to know that it is an entire function, then you will be very happy. Sir, it is an entire function, then what MT said? MT said x is z, z is x, y is 0. X, z both are interchangeable, y should be 0. That's it. So MT will make you feel very good if it is an entire function. Very very important condition, entire function. Or it could be analytic in a particular domain. Let's just say I am defining a particular domain. In this domain it is analytic. Okay. Let's see these kind of questions which are very very famous. Okay. So this is a certain type of question which are very famous. What is given? That f of z is analytic. They have given you the real part, like f of z is u plus iota v. U plus iota v. You know the u value, but you don't know v value. This is known, this is not known. But you need to find out f of z. If you need to find out f of z, that means you need the value of v. So I need the value of v. This is my target. So method 1. What is the method 1? I need to find out v. You know that v is a function of x comma y. Now do you remember something? Let's just say some function is a function of x comma y. Some variable is a function of x comma y. Then what we used to do? That sir, this variable could be written as, you partially differentiate your f with respect to x, then multiply with dx, and partially differentiate your f with respect to y, and then multiply with dy. So I used to say that this and this is getting cancelled out, this and this is getting cancelled out, so you will get the function f only. That means I know that my v is a function of x comma y. Then what you would do? You will partially differentiate your function v with respect to x dot dx, plus partially differentiate your function v with respect to y dot dy. You will get the function v only. In the differential calculus we have studied it. Different way we have studied. No, if it is a function of t, then how we will solve it? A complete way I have given you. And this was the very important line. This I used to write down again and again. Do you remember it or not? Say yes or no. Right? This will be not your v, this will be your dv, sorry. This will be your dv. And if you need to find out v, then what you will have to do? You will have to integrate. So what will be your dv? Your dv would be partial differentiation of v with respect to x dot dx plus partial differentiation of v with respect to y dot dy. This will be your dv, not v. This will be your dv. You will have to integrate if you need to find out v. Understandable? Say yes or no. Can I write it down in this way? Partial differentiation of v with respect to x plus partial differentiation of v with respect to y. So this line again and again I will be writing down. Similarly, I can write down for u as well. No, what will be the line for u? Partial differentiation of u with respect to x dot dx plus partial differentiation of u with respect to y dot dy. Similar line I can write down for u as well. Now since your f of z is analytic, since it is analytic, then you know one thing. What do you know? Since it is analytic, then sir, I know that ux would be equals to vy, and vx would be equals to minus ui. This I already know. Or if you don't remember, you can do in this manner: ux, vx, ui, vy. So ux would be equals to vy, ux would be equals to vy, ui should be equals to minus vx. So in place of ux, you will put v. Sorry, you are having the value of ux, no? So in place of vx, what you can put? Minus ui dot dx, plus in place of vy, what you can put? Ux dot dy. Is that understandable to you? In place of Vx, sir, I can get the value of Ui. How I can get the value of Ui? Because sir, U is given, no? What is U? So U is x square minus y square. So sir, I can get the value of ux, that will be 2x, and sir, I can get the value of ui, so that will come out to be, ui will come out to be minus 2y. So sir, these values I am having. So in place of vx, what I am replacing? In place of vx, I am replacing ui. In place of vy, I am replacing ux. So what is your dv? So dv is coming out to be, what is the value of ui? Sir, ui is minus 2y. So in place of minus ui, what you will put? 2y dx. So it is coming out to be 2y dx. Basically, in place of ui, I am putting minus 2y here. So it is coming out to be 2y dx plus, what is the value of ux? That is 2x. So plus 2x dy. This is what you are getting. This is your dv. From here, you need to get the value of v. How will you solve it now? That means you have to integrate on both of the side. 2y dx plus 2x dy. Okay. Now, sir, I don't know how to solve it. So this we will study in differential equation, that how you solve this equation. In differential equation, we will study, which is our next chapter. Okay. So this is known as exact equation. What it is known as? Exact equation. How to check whether an equation is exact or not, that also I will tell you. But this is known as exact equation. How to solve an exact equation? So with respect to dx, what you will do? You will keep y as constant. When you are integrating with respect to x, no, then what you will do? You will keep y as constant. Y will be treated as constant. And when you are integrating with respect to y, then what you will do? All the functions of x will go to 0. All the terms related to x will go to 0. Let's just say in place of 2x dy, if it was 2 cos x dy, then in place of x you will not put 0. Whatever the function of x is there, no, that will go to 0. Whatever the function of x, whatever, if it was fx plus y dot dy, if this was the scenario, then whatever the function of x is, no, that will go to 0. That means you are nullifying the effect of x. You are nullifying the effect of x. You are not putting x equals to 0. You are nullifying the effect of x. So this will go to 0. So what you are left with? Sir, v will simply come out to be, y will be treated as constant, plus this will be 0 only. This will be completely 0, because if x is going to 0, 0 into dy will be 0 only. What answer you are getting? So v is coming out to be 2yx plus some constant value is also possible. So this is the value of v you are getting, which is 2xy plus c. This is your v. This is the v that you are getting. Okay, you can put it here. This is the v we are getting. So what we have seen now? What will be our f of z? So f of z will come out to be u plus iota v. What is the value of u? So value of u was given x square minus y square, x square minus y square, and sir, value of v I am getting is 2xy plus some constant value is also there. So I can write down this as x square minus y square plus iota 2xy plus iota into constant. It will be a bigger constant, so I am just writing it down as bigger c. It will be a constant only, no? It will be a constant only. It will be a constant only. So this is your f of z. So this is the f of z that you are getting. So did you understand how did I find out the value of v? It is very simple, sir. You need to find out the value of v. Value of v is a function of x comma y. That means you can write it down as partial differentiation of v with respect to x dot dx plus partial differentiation of v with respect to y dot dy. Now, sir, what I can get? Sir, I am given the value of u. So with the help of u, I can get, sir, ux and uy. Now, is there any relation? Absolutely, sir. Vx would be replaced with u minus uy. Vy would be replaced with ux. Can I put these values? Yes, sir. Can I integrate? Job done. Now, sir, I know that this is analytic, no? I know that this is analytic. Since it is analytic, then what empty said? Empty said one thing, that x could be replaced with z and y could be replaced with 0. So as per empty, what I am going to do? X will be replaced with z, y will be replaced with 0 plus iota. X will be replaced with z, y will be replaced with 0 plus c. So this is 0, this is 0. So from here, f of z is coming out to be z square plus some constant. There you go. This is your f of z. In the examination, it might happen that only z square is written. That means you need to assume that constant is 0. It could be any constant value. Like you know that z square is an analytic function. Then z square plus 2 will also be analytic. Z square plus 9 will also be analytic. So this constant will not change anything. Understandable? Okay, so this is your f of z, which is z square plus c. This will be the answer. Is that clear to you or not? Understandable? Very straightforward methods. There is nothing here. I need to find out the value of v. This is something that I can do. Partial differentiation of v with respect to x dot dx, partial differentiation of v with respect to y dot dy. Now I have the relation between u and v. U is already given, so sir, I can find out some relation. You can put those relation, job done. Okay. And after finding it in the terms of x and y, you already know that it is analytic. So x could be replaced with z, y could be replaced with 0, job done. Method 2. This method is also very famous. Differentiation method, I will call it. Here what you are going to do, you are going to do the differentiation. What does that mean? F of z is given as u plus iota v, right? You differentiate on both of the sides with respect to z. What I am doing, I am differentiating with respect to z. So this will become uz, no? And this will become vz. But I told you, if it is analytic, it is already given that it is analytic. It is given in the question that f of z is analytic. And if it is analytic, then you know that one thing, what our MT said. MT said that x is z, y is 0. So x is z. So in place of partially differentiating them with respect to z, I will partially differentiate them with respect to x. So in place of z, what I will put? I will put x. Since they are analytic, so here I am differentiating with respect to z, but here I will differentiate with respect to x. Now what is given? U is given. U is given x square minus y square. Do you have the value of vx? I don't have the value of vx. I have this value. This is a certain method that first we will differentiate. After that, the path will become clear to you. I have the value of ux. Yes, sir. Ux will be nothing but 2x only. Do I have the value of vx? No. But what do I know? I know one thing, that's sir, ux, vx, uy, vy. Sir, what do I need? I need the value of vx. Sir, I know that vx would be equal to nothing but minus uy. Minus uy. So partial differentiation of u with respect to y will be minus 2y. And from here I know one thing. What do I know? From here I know that my vx would be equal to minus uy, which will be equal to 2y. Okay. So from here what I am getting, my f of z is coming out to be ux is nothing but 2x plus iota. Sir, vx I was not having. Vx equals to minus uy. Ui I find out it was minus 2y. So this is coming out to be 2y. This is the differentiation that you are getting. MT again, since it is analytic. Look, if f of z is analytic, no, then f dash z will also be analytic only. Okay. Since it is analytic, x is z, y is 0. So in place of x, you will put z. And in place of y, you will put 0. So f dash z would be equals to 2z. Now if you need to find out fz, what you need to do? You need to integrate on both of the sides. Right? So what answer you will be getting? The answer will come out to be 2 into z square by 2 plus c. So answer is z square plus c. That means f of z is coming out to be nothing but z square plus c. There you go. That's the answer. Here also the same answer was there. This was a bit shorter method, right? MT said, if your function is analytic, no, then be very happy. X is z, y is 0. So replace x with z and y is 0. So here you are partially differentiating with respect to z, but actually you partially differentiate with respect to x. Ux value I already have, vx value I don't have. I can use the property, I will get the value of vx as well. Again, sir, if this is f of z, it will also be analytic. X is z, y is z, y is 0. In place of x, you put z. So f dash z is 2z. Now you need to find out fz, integrate both of the side, job done. Okay. At least you would find that 30 PYQs have been asked on this topic. Only this topic, whichever that we have discussed in last 15 minutes, no. On this discussion only, at least 30 PYQs have been asked. I don't know what they see. Always they ask this kind of question only. From analytic function, they ask this question. This is very famous kind of question. From analytic function, from this topic, they ask this question only. What they would do, they will give you the expression of u, they will give the expression of v, job done. Sorry, they will give you the expression of u, they will give the f of z is analytic, then they will ask the expression of v, or they can ask f of z. This two method I have taught you. Whichever the method you want to use, you can use it. Okay. Method 2 is a bit easier, so you can prefer this method. Let's go to the next function. Similar kind of function. This time imaginary part is given. You need to find out f of z. Do it on your own. If you are looking at the solution, then there is a problem, because it is very straightforward, no? Okay. So let's apply method 1. What will be the method 1? Method 1 will say that you need to find out value of u. which you are not having. That means what you will do, partial differentiation of u with respect to x dot dx plus partial differentiation of u with respect to y dot dy. Sir, I have the value of v only. What do I know? Sir, ux, uy, vx, vy. Sir, I know one thing, that ux would be equals to vy, ux would be equals to vy, and sir, ui would be equals to minus vx, ui equals to minus vx. So this will be my du. Sir, what is the value of vy? Partial differentiation of v with respect to y. So that would be 4x plus 4y. 4x plus 4y. Partial differentiation of v with respect to x. That would be, sir, minus 4x, sorry, partial differentiation of v with respect to x. So that would be 4y minus 4x. With respect to x you are doing, no? So y will be taken as a constant, 4y will be taken as a constant, partial differentiation of x will be 1, and this will give you 4x, this will give you 0. Understandable? So what we are putting, du would come out to be 4 you can take outside, x plus y dot dx minus 4 you can take outside, y minus x dot dy. Right? Now what will be your u? U will be 4 x plus y dot dx minus 4 y minus x dot dy, y minus x dot dy. Did I tell you how to solve this equation? Here you will treat y as constant, here you will treat y as constant, and here what you will do, treating y as constant, and here what you will do, function of x will go to 0. So function of x, this is the function of x, this will go to 0. Only the function of x, you will not do anything with y. So what you are getting, u is coming out to be 4 is outside, no, 4 x dx plus 4 y dy, sorry, 4 y dx. This is your x plus y, no, x plus y. So 4x dot dx plus 4y dot dx, 4y dot dx minus 4y dot dy, minus 4y dot dy, minus 4, this x goes to 0, minus 4y dot dy. Understandable? Everything is clear here. Y will be treated as constant here. What is written? Y will be treated as constant. So what you will do, this will come out to be 4x square by 2, so this will become 2x square, plus y will be treated as constant, so 4y will come outside, integration of dx would be x only, and here you will get 2y square. This is the answer of u you are getting. That's it. This is your u. 4x square by 2, that would be 2x square plus 4, y will be treated as constant, integration of dx would be x, minus 4y square by 2 minus 2y square. This is the value of u you are getting. Okay. So what is your f of z? F of z is u plus iota v, which will come out to be what? 2x square plus 4yx minus 2y square plus iota v is nothing but, what is v? 4xy minus 2x square, 4xy minus 2x square plus 2y square plus 2y square. Since it is analytic, our empty said that x is z, y is 0. So x is z. If you put y equals to 0 here, what you will get? 4 into 0 into x is z minus 2 into 0 square plus iota 4, in place of x you will put z, and y is 0, minus 2, in place of x you will put z, y is 0, plus 2, y is 0 whole square. Right? So this is 0 only, this is 0 only. What it will become? Minus 2z square, it will become, this will be also 0, this will be also 0. So 2z square plus 2z square minus iota 2z square. This is what you are getting, right? 2z square minus iota 2z square. So 2 into 1 minus iota z square. This is your f of z. This is the answer. 2 into 1 minus iota z square. This is the answer. Is that understandable to you? 2 into 1 minus iota z square. I hope the calculation is correct only. But let's check with method 2. Let's check with method 2, which would be easier. What our method 2 is? Sir, f of z would be u plus iota v. You partially differentiate with respect to z, but in my mind I know that x is z and y is 0. X is z and y is 0. This I always remember. Y is 0. Okay, so partial differentiation of u with respect to x, that I am not having, but partial differentiation of u with respect to ux would be equals to ux ui vx vy. So I know that sir ux would be equals to nothing but vy only, and vx value I am already having. So what is the value of vx? Value of vx when I partially differentiate, it came out to be 4x plus 4y. So value of vx came out to be 4x plus 4y. And what is the value of you need the value of ux, which will be equals to vy, and value of vy came out to be 4y minus 4x. 4y minus 4x. So just put it here. Value of ux is 4y minus 4x. 4y minus 4x plus iota. What is the value of ux? That would be 4x plus 4y. X is z, y is 0. So what is your f of z? F dash z. Sir, y is 0, x is z. So minus 4z plus iota. Sir, x is z, y is 0. So 4z, right? In place of x you put z, y is 0. In place of x you put z, y is 0. So what you can do, you can take z as common. What you will be getting? 4 into minus 1 plus iota. So minus 4 I can take outside, no? Or I am taking 1 as outside. So minus 1 plus iota. This is what I am getting. 4 I have taken as outside. So minus 1 plus iota. Is that clear? No, nothing wrong, right? Vx, what was our Vx? Okay. Opposite I have written, I guess. Vx is 4y minus, Vx is 4y minus 4x. Sorry guys. This is opposite. What was our Vx? This is our V, no? So what will be our Vx? Vx will be 4y minus 4x. 4y minus 4x. This will be our 4y minus 4x. And the other one is 4y plus 4x. So this is, here you will get plus sign and here you will get minus sign. Just a small blunder I have done. So x is z, this is fine, and here also you will get the positive sign only. Is that understandable to you? 4y minus ux, 4y minus 4x, 4y minus 4x, 4, this is your 4. Okay, this is not u, this is 4. Okay, I hope you are not getting confused between, this is 4, right? Now in place of x I am putting z, so this sign will be negative in place of x. Yeah, now this is fine. So 4 you take outside, inside it would be 1 minus iota into z. 4 you take outside, inside this would be 1 minus iota into z. This is your f dash z. Now what will be your f of z? Sir, f of z would be simply you integrate it. So 4 into 1 minus iota z square by 2 plus some constant c. So what is the answer you are getting? 2 into 1 minus iota z square plus some constant c. So this is your f of z that you are getting. There you go. Is it same? Absolutely, sir. This is also same. Here also you will get some constant c, no? When you are integrating, you will get some constant c. So some constant c will be available here as well. So here as well some constant c would be available. This will not change anything actually. The constant c would be there. Constant c would be also there. So within seconds, not within seconds, within a minute you can solve this particular process. This is a bit lengthy. This is a bit lengthy process, but this would be easier process. So if they are asking f of z, no, in the examination if they are asking f of z, then I would go by this method. But in the examination if they are asking the expression of v, if they are asking this expression, which expression? If they are asking the expression of u, if this expression they were asking, no, then I would go with this method. Because here I will have to convert into f of z, then I will put the value of z as x plus iota y, then I will get the imaginary part. But in the examination, if they are asking f of z, then this method I will use. And in the examination, if they are asking the real part or imaginary part, then I will use this method. Understandable? It is completely understandable to all the students. Very simple. V is given, you need to find out u. U is given, you need to find out v. Very simple process. Ux, ui, vx, vy, there is a relation. You can write down the expression of u in this manner and job would be done. Empty method also I have taught. Okay. Next question. What they are asking? They are asking the value of imaginary part at z equals to 2 plus iota. That means you need the value of imaginary part, no? What is imaginary part? That is v. So here method 1 will be helpful because I need to find out the value of v. And when I find out the value of v, what is z is? Z is 2 plus iota, that means x value is 2, y value is 1. So find out the value of v. In place of x you put 2, in place of y you put 1, job done. So method 1 would be easier for me here. Method 1 would be easier. I need to find out v, no? So that would be partial differentiation of v with respect to x dot dx plus partial differentiation of v with respect to y dot dy. So ux, uy, vx, vy. So your vx would be equals to minus uy dx, and vy would be equals to ux. So ux dot dy. This will be your dv. So what will be your partial differentiation of u with respect to y? That would be minus 6xy, and partial differentiation of u with respect to x, that would be nothing but 3x square minus 3y square, right? With respect to x you are doing. So you put it here, dv would be equals to 6xy dx plus ux is 3x square minus 3y square dot dy. You need to find out the value of v. Then what you will do? You will integrate. This is your y will be treated as constant. And here function of x will be going to 0, right? This will be going to 0. So what answer you will be getting? 6y multiply with x square by 2. Y will be treated as constant, so 6y x square by 2 minus 3y square dy. So this will be 3y cube divided by 3. So this will be y cube. Understandable? So what answer you are getting? 3yx square minus y cube. This is the value of v we are getting. So this is your v. So what v we have got? V we have got is 3yx square minus y cube. I hope you are able to understand method I have taught. This is exact differential equation. Okay. In the next chapter we will study it. Not in the next chapter. In the next chapter only. So in the next chapter we will study it. In this chapter we are not studying. So y as constant you treat 6y goes outside. So this will become 3yx square. Then here it will become y cube, because function of x should be kept as 0. So this will become simply y cube only, because integration would simply result in y cube. So 3yx square minus y cube. In place of now what we need to do? Our v is coming out to be 3yx square minus y cube. Now in place of x we need to put 2, and in place of y we need to put 1. In place of x we need to put 2, in place of y we need to put 1. In place of y we need to put 1. So 12 minus 1, answer is 11. This is the answer. What is the answer? Answer is 11. Okay. So answer is 11. That's the answer. So here method 1 will be helpful. No, it will be easier. In method 2, what will be the problem here? That you will find out f of z first. That your f of z is u plus iota v. No. Now you will have to differentiate. First of all, you will have to differentiate. So what differentiation will say? Ux plus iota vx. Now what is given? U is given. So ux, vx, uy, vy. You already know that if I need the value of vx, so that would be equals to minus uy. Now do you have the value of ux? Yes sir, the value of ux is nothing but 3x square minus 3y square. So here I can put the value 3x square minus 3y square plus iota. What will be the value of vx? Value of vx will be equals to minus uy. Uy is 6xy minus 6xy, so this will come out to be 6xy. Say yes or no? Okay. Now f dash of z. Now I know one thing, that x will be replaced as z, 3 into 0 plus iota. This will also be 6 into z into 0 only. So what is the answer you are getting? Sir, f dash z is coming out to be 3z square. So what is the value of f of z you are getting? So that would be z cube plus c. So f of z you have got as z cube plus c. This is what you have got. Now what you will have to do? In place of x, you need to put x plus iota y cube plus c. Then you will have to solve a cube plus b cube. Let's go to the next page. Yes. So this is something that we are supposed to solve. I hope the calculation is going in a correct way only. This will be 0, 3z square and z cube. Okay. So a cube plus b cube plus 3a square b plus 3ab square. I only need the, what will be I cube? I cube will be minus iota y cube plus iota 3x square y minus 3x y square. So I only need the imaginary part, no? So what is the imaginary part you are getting? What is the imaginary part? Imaginary part from here I am getting is 3x square y minus y cube. The same expression we are getting, no? Same expression, 3x square y minus y cube. 3x square y minus y cube. The same expression. Constant c is also there, which will not make any impact. This will be going into the real part only. So this is going into the real part. I need the imaginary part. Imaginary part is coming out to be same, 3x square minus y cube. And here you can check the value at x equals to 2 and y equals to 1. Right? So answer is 11. That's the answer. Say yes or no. Okay, so although it came out to be on the easier side only, but who knows, this expression might be difficult. Then here only you need to take a cube. So it came out to be easier. But what if this expression was difficult? If this was difficult, then there would have been problem. Right? So I would say prefer method 1 when you need to find out the value of v, imaginary part or the real part. Otherwise, if you need to find out the value of f of z, no, then this would have been the best method. Here you would take a lot of time. You will find out the value of v, then you will write down u plus iota v, then you will replace x with z, y with 0. But here directly you can find out the value of f of z. So you would have understood when to prefer which method. If this question is asked analytic function, this is a different kind of question. Find out the value of k. You should be able to solve it. There is nothing difficult here. You need to find out the value of k. F of z is given. Nothing difficult, very straightforward. F of z is given, which is e to the power minus kx cos 2y plus iota minus sign outside e to the power minus kx sin 2y. Say yes or no. E to the power minus kx cos 2y plus iota plus iota minus sign outside e to the power minus kx sin 2y. So this is your u and this is your v. U plus iota v. You need to find out the value of k. What do you know? If it is analytic, then ux, uy, vx, vy. So ux would be equals to vy and vx would be equals to minus ui. So can you find out the value of ux? Yes sir. Partial differentiation of u with respect to x. Cos 2y will be treated as it is, minus k outside. So e to the power minus kx cos 2y. Now partial differentiation of u with respect to y. What will happen? E to the power minus kx as it is, cos 2y will be sin 2y with minus 2 outside. E to the power minus kx as it is, differentiation of cos 2y will be minus 2 sin 2y. Now partial differentiation of v with respect to x, what you will get? K e to the power minus kx sin 2y, and partial differentiation of v with respect to y, minus e to the power minus kx cos 2y 2. Okay, now you know that both of the guys will be same. That means ux will be equals to vy. What is the value of ux? Minus k e to the power minus kx cos 2y would be equals to minus 2 e to the power minus kx cos 2y. Now you just see cos 2y same, e to the power minus kx, e to the power minus kx same. What does that mean? What is the value of k? Value of k is 2 only. There you go. Value of k is 2 only. From here as well you can see sin 2y same, e to the power minus kx. This will be kx, no? So sin 2y same, e to the power minus kx, e to the power minus kx same. K will be equals to plus 2, because here you will use negative sign, no? Because vx is equals to minus uy. Vx is equals to minus uy. So here you will use the negative sign. So k is coming out to be 2 only. So this is the answer. Very simple question. K is 2. So just separate the real and imaginary part. Job done. Very simple process. Very simple process. Next question. Solve this question. It is very interesting question. Not very interesting. Just one thing you need to take care. If you look at this question, no, like if you don't notice much things, then you will directly click that it is an entire function. But it is not an entire function. F of x comma y, x divided by x square plus y square plus iota y divided by x square plus y square. So you find out these values, no? What is your f of x comma y? X divided by x square plus y square plus iota minus y upon x square plus y square. So this is your u and this is your v. Now do the partial differentiation. You can do it on your own. Partial differentiation of u with respect to x. What you will be getting? X square plus y square whole square, x square plus y square. Partial differentiation of u with respect to x, this will be 1 minus 2x here. So what answer you are getting? Minus x square plus y square upon x square plus y square whole square. Okay. This is your partial differentiation of u with respect to x. Now partial differentiation of u with respect to y. So x will be treated as constant. So what answer you will be getting? Minus x upon x square plus y square whole square into 2y. Did you understand what I do? A upon a square plus x square. This is the differentiation I need to do. So what will be the answer? Minus, like first I am different. A is a constant. No, a is a constant. So I am differentiating 1 upon a square plus x square. What is the answer I will be getting? A square plus x square whole square, because what is the differentiation of 1 by x? That is minus 1 by x square. So similarly, what is the differentiation of 1 by fx? That will be minus 1 by fx whole square, and then differentiation of fx. So which will be 2x. So similar thing. X is treated as constant. So x upon x square plus y square whole square with the negative sign, then differentiation of this function. What will be the differentiation of this function? That would be 2y. So this is what you will be getting. Understandable? So x is treated as constant. You treat x as constant, and this is the answer you are getting. Minus 2xy upon x square plus y square whole square. Now partial differentiation of v with respect to x. So y will be treated as constant. So here answer you will be getting is y upon x square plus y square whole square multiply with 2x. So answer you are getting is 2xy upon x square plus y square whole square. 2xy upon, and what about vy? So when you solve partial differentiation with respect to y, you can do it on your own. You will get this answer only. Minus x square plus y square upon x square plus y square whole square. You can do it. No, you need to differentiate with respect to y. So x square plus y square will be here only with the square. Then upper side what you will get, x square plus y square. Then partial differentiation of minus y will be minus 1. Then minus sign, minus y remains as it is. Then here the partial differentiation with respect to y will be 2y. So what answer are you getting? Minus y square plus 2y square. So yeah, y square minus x square divided by x square plus y square whole square. So same answer you will get. So here what you can see, that sir, I can see irrespective of the values of x and y, irrespective of the value of x and y, they are same. This is also same, and this is having a negative sign difference. That means ux would be equals to vy irrespective of the sign, and uy will be equals to minus vx. So sir, it is the entire function irrespective of the value of x and y. That means it is always differentiable. So it is the entire function, which is wrong. Why is that so? It is not an entire function because they are not continuous at 0, 0. No, not continuous at 0, 0, because at 0, 0, 0 plus 0 whole square will be 0 only. So it will become 0 by 0, which is a undefined form. Indeterminate form is 0 plus divided by 0 plus. Undefined is 0 by 0. This discussion we have already done, right? So it will become undefined at 0, 0. That means it is not continuous at 0, 0. So all these functions are not continuous at 0, 0. What does that mean? That means it will not be differentiable at 0, 0. Not differentiable at 0, 0. What does that mean? That means it will be not analytic at 0, 0. Not analytic at 0, 0. Rest all the points they are analytic, but not at 0, 0. So f of x, y is analytic everywhere except 0, 0. Okay, and this option is wrong. So it is not an entire function, and it is analytic everywhere except 0, 0. So this was the question that we have solved. Just a practice question so that you don't mess up in the examination. Always check their continuity as well. Don't forget to check the continuity. Next, find the value of a and b. F of z is given. This is your u, this is your v. Again the same kind of questions are ux, which is coming out to be 2x, ui, which will come out to be 2ay, vx, which will come out to be ux, ui, vx will come out to be by, and sir, vy, which will come out to be bx. This should be equals to this one, and this should be equals to minus of this. So from here what you are getting, that sir, 2x should be equals to bx, That means, sir, the value of b is coming out to be 2. It is analytic, no? It is given, it is analytic. That means b is coming out to be 2. And from here, by should be equals to minus 2ay. That means a should be coming out to be minus b by 2, which is minus 1. So value of a is minus 1. There you go. Very straightforward question. Very, very straightforward question. A is minus 1, b is 2. Okay. Now let's just say in the examination the same question is coming. It is actually a gate PYQ. This question came in the examination. But what if I frame the question in this manner? That means your f of z is given. This time I have given the expression of u, but I did not give the expression of v. What you will do now? Someone would say that, sir, if I am having the expression of u, no, then I can find out the expression of v. And then I can solve in this manner. Sir, u is given. Can I find out v? Yes, sir. It would be vx dx plus vy dy. Sir, this would be equals to minus ui. And sir, this will be equals to ux. So I know these values. From here I can find out the value of v. Sir, ui is given, partial differentiation of u with respect to y. This will be 2ay dx with a negative sign plus 2x dy. If I integrate this, then answer I am getting, sir, this will be treated as 0, x will be treated as 0. And now you need to differentiate this, you need to integrate this. So answer is minus 2ayx. Okay, and this will be treated as 0. So this will be your v. So, plus c as well. So this is your v you are getting. So value of v is coming out to be minus 2axy plus c. This is the value of v you are getting. And then, sir, I know one thing. Simple process. Like here b equals to what you are getting. B equals to minus 2, no? So it is minus 2axy only. That's it. This is what you are getting. And then, sir, I can solve it. This is method 1. From here you can solve. Now you can solve. How you can solve? You can solve with the same thing. That, sir, ux will be equals to vy. And, sir, uy would be equals to minus vx. Using these properties you can solve. What about this one? If your f of z is analytic, then you directly know, right, that del square u will be equals to 0. Laplacian of u will be equals to 0. So can you calculate the Laplacian of this particular function? That means you need to partially differentiate u with respect to x twice, then you need to partially differentiate u with respect to y twice, and that would be equals to 0. So partial differentiate u with respect to x 2 times. So first you will get 2x, then you will get 2, plus partially differentiate u with respect to y 2 times. So first you will get 2ay, then you will get 2a, equals to 0, a equals to minus 1. So no need to follow the process, no. Just use the property. If f of z is analytic, then u will be a harmonic function. So del square u equals to 0, job done. What if v was given? Let's just say if this function was given, and I am asking you the value of a, then it is not possible, no. What I mean to say is that, let's just say in the examination, the same question has come. I will copy the same question. The same question has come in the examination, but this time they changed the data. How they changed the data? That I will tell you. Let it be copied. Yeah, this is copied now. This time, what they gave? This time they gave the value of v here. They gave the value of v, which was bxy, and they asked you the value of b now. What is the value of b? Find b. Find b. Then what you thought? That, sir, f of z is analytic. F of z is analytic. If f of z is, sir, analytic, then what I will do? Then I will do del square v equals to 0. Now you tried finding del square v. What you are getting? V plus del square by del y square v should be equals to 0. So partial differentiation of v with respect to x 2 times. So first you differentiate, you will get by, and then you partially differentiate this function with respect to x. What you will get? 0. Right? Next, partial differentiation of v with respect to y 2 times. So first you differentiate with respect to y. What you will get? Bx. Then again you differentiate with respect to y. What you will get? 0. 0 plus is 0. 0 equals to 0. That I already know, no? It will be 0 will be equals to 0. So from here you are not able to get b, no? Here what really happened? In this expression what really happened? It came out to be a function of a, so you got to know that a is minus 1. But here, no conclusion. No, nothing conclusive here. Nothing conclusive. So for that, what you need to do? You need to follow method 1. Method 1 or method 2, whatever it is, this should be followed here. That means you need to find out the value of u, which will be ux dx plus uy dy. Okay. So what will be ux? Ux will be equals to vy dx. And what will be uy? That would be vx dx. So what will be the partial differentiation of u with respect to y? That would be bx dx. With respect to x, that would be by dx. So I can write down this as, अरे भाई ये क्या कर रहा हूँ मैं, by dy, sorry guys, this is dy. Okay, now what you need to do, if you need to find out u, then what you will do, here x square by 2, and here what you will get, here you will get minus by square by 2. So you are getting b by 2 x square minus y square. So this is the value of u you are getting, and this is the value of v you have. Value of v is nothing but bxy. Now you know one thing, that ux would be equals to, since it is analytic function, so ux would be equals to vy, and vx would be equals to minus uy. So what is your ux? Ux will come out to be bx. What is uy? Uy will come out to be minus by. What is vx? Vx will come out to be nothing conclusive here as well, right? What will be your vx? Vx is coming out to be by. And what is your uy? What is your vy? Vy will come out to be bx only. So here as well you cannot make anything conclusive. So any value of b is acceptable. B could be any value, no? So basically this question doesn't make any sense. This question itself is not making any sense, because here as well there is nothing conclusive. B could be anything. So in the examination, if they want to frame this question, no, then this question only they can frame. Here the answer would be any value of b will be accepted. You put b equals to 2, 1, 3, 4, 5, any value of b will be accepted. Here as well I should be able to understand, no? Because when I applied this property, it is not dependent on the value of b. This is always 0. So any value of b will be accepted. Okay. What I said that you cannot apply this method, that was actually wrong. The correct statement would be that any value of b will be accepted if this question they are asking. Understandable? Because here as well they will be always equal, no matter whatever the value of b is there. So any value of b will be accepted. So this question they will not ask, they will ask this question. Understandable? Or if I want to ask this question, no, then I will frame it as a MSQ. What I will do, I will frame it as a MSQ. Then I will say, what is the possible value of b? Option A 1, option B 2, option C 3, option D 4. 1, 2, 3, 4, all options will be correct. Okay. So I will frame it as a MSQ if I want to frame this question. Understandable? Let's go to the next one. Think about it. F of z equals to 2z cube plus b mod of z cube. If it is analytic, find out the value of b. Think about it. Think. Don't use the pen. Think. It is a NAT type of question. F of z equals to 2z cube plus b. This is the scenario. Now you know that, sir, it is polynomial in z. It is polynomial in z. Polynomial. Only this much I am talking about. 2z cube. It is your polynomial in z. That means, sir, I know that this is surely analytic. And sir, if I remember, mod of z was not analytic, because it is not the polynomial in z. No, this is polynomial in z. This is polynomial in mod of z. So this is not analytic. This part is not analytic. This part is creating the problem. Not analytic. This part is creating the problem. Now I need to put the value of b. What value I will put such that this problem is gone? I will simply put b equals to 0. If I put b equals to 0, what will be my f of z? F of z will simply become 2z cube. It will become analytic. That's it. So what do you want? You want the value of b equals to 0. That's it. This is the answer. If you start using the pen, then it will take a lot of time. Not a lot of time, it will take some time. What I will do, I will convert it into a function of x comma y. So you know that x plus iota y whole cube plus b mod of z whole cube is there, no? So it would be x square plus y square to the power 3 by 2. Because what is mod of z? Mod of z is nothing but under root x square plus y square. Right? So it will become to the power 3 by 2. So from here, if you solve, then what you will get, you will convert it into u plus iota v format. How will you convert? To x square minus y square plus 2 iota xy plus b x square plus y square to the power 3 by 2. So what you are getting? 2x square minus 2y square plus b x square plus y square to the power 3 by 2 plus iota 4xy, right? So this is your u, this is your v. So u plus iota v, right? So then from here what you can apply? Ux, uy, vx, vy. So you can differentiate and everything, then you can equate them, you will get the value of b to be 0 only. Okay. In polar coordinate also I can solve. If I see this question no, in the examination only, if I want to go with the with this approach only, then what I would do? I would solve it with the polar coordinate system. Another method, I will convert my function. I will convert my function into r comma theta. What is given? 2z cube is given, no? So 2 in place of z I will put it r e to the power iota theta cube plus b. What is mode of z? Mode of z is r only plus br cube. So this method I would prefer. Let's see if I get it easier or not. So 2r cube e to the power iota theta plus br cube. So 2r cube e to the power iota theta would be cos theta plus iota sine 3 theta plus br cube. So answer is 2r cube cos 3 theta plus br cube plus iota 2r cube sine 3 theta. So this will be your u plus iota v. So partial differentiation of u with respect to r will be 6r square cos 3 theta plus 3br square. Okay. Then partial differentiation of u with respect to theta. What answer I will get? 6r cube sine 3 theta with the negative sign, and with respect to theta this will be 0. Then partial differentiation of v with respect to r. What answer you will get? 6r square sine 3 theta, and partial differentiation of v with respect to theta, you will get 6r cube cos 3 theta. 6r square, sorry. No, 6r cube cos 3 theta. Yeah, this is something that you will be getting. Now you know one thing, that sir r ur would be equals to v theta. So r ur, that means 6r cube cos 3 theta plus 3br cube would be equals to v theta, which is 6r cube cos 3 theta. This and this is getting cancelled out. From here you are getting 2br cube should be equals to 0. That means b has to be equals to 0. So this method also I could have used, which is not a very good method. Okay. If using our brain, we can directly see that it would be equals to 0. Using our, this is another method, method 3. This was your method 2. So different methods I have given, but again using our brain directly I can see that sir, this is creating the problem. Ignore it. So value of p would be 0. Otherwise you can go with the polar coordinate system as well. I hope you remember r ur would be equals to v theta, and r vr would be equals to minus u theta. That is the analytic function, or that is the CR equation. Next question. So this is like a prerequisite to the next problem. Like this is the question that has been asked in GATE examination. It is like a prerequisite to the next question. So read this carefully and let me know what is the correct answer. Function of x I have given, f of x comma y I have given, g of x comma y I have given, and h of x comma y is f of x comma y plus g of x comma y. Which of the following statement is true? The first option is that f of x comma y is differentiable only at 0 comma 0. What you need to find out? You need to find out the differentiability of f of x comma y. What is your f of x comma y? You are only discussing about f of x comma y. F of x comma y. You are only discussing about f of x comma y, which is x square minus y square. X square minus y square plus iota 0, no? Here what is the real part? Real part is x square minus y square. And what is the imaginary part? That is 0. This is the scenario. So here if you do partial differentiation of u with respect to x, what answer you will be getting? 2x. Partial differentiation of u with respect to y, what is the answer you will be getting? 2y. Partial differentiation of v with respect to x, answer is 0. Partial differentiation of v with respect to y, answer is 0. That means this part will be differentiable. They will be equal only at 0, 0. So differentiable only at 0, 0. Differentiable only at 0, 0. Only at 0, 0. That means differentiable only at 0, 0. What about g of x, y? What is your g of x, y? Sir, g of x, y is nothing but 0 plus iota 2xy. 0 plus iota 2xy. Right? What does that mean? That means, sir, my real part is 0 and my imaginary part is 2xy. So if I ask you partial differentiation of u with respect to x, that is 0. Partial differentiation of u with respect to y, that is 0. Partial differentiation of v with respect to x, that will be, sir, 2x. Sorry, that will be 2y. And partial differentiation of u with respect to y, that will be 2x. Right? This and this guy should be equal. That means x and y would be 0 only. So again, differentiable only at 0, 0. Say yes or no? Differentiable only at 0, 0. So yes, it is differentiable at 0, 0. What about h of x, y? Your h of x, y will turn out to be, sir, x square minus y square plus iota 2xy. So what is your h of x, y? If you have good knowledge, then it is z square only. Is it differentiable everywhere? Yes, sir, it is an entire function. Entire function. That means yes, it is differentiable everywhere. So if I say one thing, that this is differentiable at z equals to 1, but this is not differentiable at z equals to 1, and this is also not differentiable at z equals to 1. Are you able to understand this point? Not differentiable, addition of that is becoming differentiable. Is that understandable to you? Now let's go to the next question. Let's read the statement of next question carefully and let's try to answer what they are saying. Two functions, they are adding up. F, G, H are complex functions of a complex variable z. Which of the following statements are true? If f of z is differentiable at z equals to z naught, if it is differentiable at z equals to z naught, then gh and hz will also be differentiable at z equals to z naught. This is what they are saying. Is this true? Option A. Let our gz is 1 by z and hz is z minus 1 by z, or z square minus 1 by z, z square minus 1 by z. You know that it is not differentiable at z equals to 0, no? At z equals to 0 there is a problem. At z equals to 0 there is a problem. But if I find out f of z, what is f of z? Addition of both of them. So what answer I will be getting? 1 by z plus z square minus 1 by z. So my f of z will come out to be z square. It is differentiable everywhere. Differentiable everywhere. Differentiable at z equals to 0. So if this guy is differentiable at z equals to 0, if this guy is differentiable at z equals to 0, doesn't mean that this will also be differentiable at z equals to 0. So this is wrong. Next, if gz and hz are differentiable at z equals to z naught, then f of z will also be differentiable at z equals to z naught. Yes, this statement is true. If they are differentiable, no. What did I tell you? Do you remember one statement? That addition, subtraction, or multiplication of entire function will be entire function only. Of entire function will be entire function only. That means if this is differentiable plus this is differentiable, then this has to be differentiable only. This is correct. Next, if f of z is continuous at z equals to z naught, then it is differentiable as well. Absolutely not. If something is continuous, then it will not make you differentiable as well. Like in the continuous time as well, you can see, not continuous time, in the real variable also you can see, this is the graph of mod of x. So it is continuous here, but it is not differentiable. Like if something is differentiable, no, then surely it will be continuous. But if something is continuous, then it might not be differentiable as well. So yes, it was continuous, but it was not differentiable here. So this statement is absolutely wrong, which is very simple. Last, if f of z is differentiable at z equals to z naught, then its real and imaginary part are also differentiable at z equals to z naught. Is this statement true? F of z is differentiable at z equals to z naught. F of z, see this example, or let's take example option D. F of z, which is z square, it is differentiable everywhere. right? It is differentiable everywhere. Differentiable everywhere. But what will be its real and imaginary part? Real part will be x square minus y square. Imaginary part would be 2xy. Is it differentiable everywhere? Is it differentiable everywhere? It is only differentiable at 0, 0. Here we have seen, no, it is only differentiable at 0, 0. That means it is differentiable at z equals to 1. Yes, but your real part at z equals to 1, is it differentiable? No. At z equals to 1, is it differentiable? No. Both are not differentiable at z equals to 1. So what is the statement? At z equals to z naught, it is differentiable. At z equals to z naught, yes, this complete function is differentiable, but its real and imaginary part also differentiable? No. Real and imaginary part. Real and imaginary part. Are they differentiable? Are they differentiable? No. They are not differentiable. Right? We have checked it here. This question I have taken only to explain the last part only. So this is also not correct. Although I put it as a MSQ, but actually only one option is correct. Understandable? Yeah, so these slides I have completed. What I will do, I will change the slide now and we will solve some more questions. I need to take a call as well. So I will change the slides and then we will solve more questions. But as of now, these slides are completed. Okay. Okay, then I will change the slide and then I will come back. More questions we will solve. Yeah, welcome back. So what we are doing, we are continuing our lecture. We need to solve this question now. Which of the following function is analytic in the region mod of z less than equals to 1? That means this time they have given that domain. This is your domain, right? Mod of z less than equals to 1. That means you need to check only in this region. What is my region, sir? It is a circle with the center at 0, 0 and radius of 1. So you need to draw a circle. Although it is not a circle, it is a disk. So first you will draw a circle which is having a center of 0, 0 and the radius of 1. Now inside this circle, whatever the points are lying, no? Inside this circle, whatever the points are lying. At all the points, you need to check whether the function is analytic or not. At all the points, at all these points. Whether this function is analytic or not at all these points. This is what you are supposed to check. Understandable? Now I know one thing. What do I know? That checking the analytic function or not, that will be a hectic task. What I mean to say is that how do you check analyticity? If a function is analytic or not, what you will do? The f of z would be given. First you will convert it into f of x comma y. That means you will convert it into u plus iota v. Right? Then you will calculate ux, uy, vx and vy. Right? Understandable? And then based on that you will be able to comment whether it is analytic or not. It is a long process, right? It is a long process. What if I say that my function is not continuous at a particular point? At a particular point my function is not continuous. You know that if a function is not continuous, that means it will surely be not differentiable as well. At a particular point we are talking, it will surely be not differentiable as well. And if it is not differentiable at that particular point, that means it will not be analytic as well. So from now onwards, in the whole chapter of complex integration or complex analysis, from now onwards my target would be that if I need to check the analyticity, I will think of the continuity. Instead of thinking of anything else, I will think of the continuity when I am checking the analyticity. Because the point is that if you talk separately, like if you just talk about z square minus 1, is it an entire function? Yes, sir. Z, is it an entire function? Yes. Is it an entire function? Yes. Because all these are polynomial, no? So separately they are entire function. That means separately they are analytic everywhere. Who will create the problem? The denominator will create the problem. No, this guy will create the problem. Because at some point, at z equals to 0, this will go to infinity. At z equals to minus 0.9 minus 0.5j, this will also go to infinity. At z equals to minus 2.5j, this will go to infinity. At z equals to minus 2, this will go to infinity. That means denominator will create the problem, no? So from now onwards, whenever I need to check the analyticity, what I will do, instead of thinking of ux, uy, vx, vy, I will think of taking the function to infinity. That means I will think of making the function not continuous. Because separately I can see that, sir, upper part is always analytic. This is also always analytic. Always analytic, always analytic. But sir, since they are written in the form of numerator by denominator, then there is a problem. Because if denominator becomes, the function is numerator of z and denominator of z. And sir, if my denominator of z becomes 0, no, then there is a problem. So if I check the analyticity, what I would do, my target would be always focused towards making that denominator equals to 0. 100% of the gate VIQs will be solved like that. And people relate analyticity with continuity. Actually, analyticity and continuity are not related. The meaning of analyticity is completely different than continuity. Right? If a question is coming, if I'm telling you one statement, you let me know whether it is correct or not. If a function is not analytic, then it will be surely not continuous. Is that correct? If a function is not analytic, then surely it will not be continuous. Wrong statement, right? Because it might happen that a function is continuous. It might happen that a function is differentiable as well. But it will not be analytic. Because what is the definition of analytic? That it should be differentiable at z0 and nearby points as well. That means it happened that the function was differentiable at z0, but here at these points the function was not differentiable. So we have seen those examples, no, where the function was continuous as well, where the function was differentiable as well, but it was not analytic. Do you remember the example of mod of z whole square? It was differentiable at, as far as I remember, it was differentiable at z equals to 0, but it was not analytic at z equals to 0. Why is that so? Because at z equals to 0.00001 plus iota 0.0001, it was saying that I am not differentiable, right? At the nearby points, it was not differentiable. So yes, it might be possible that a function would be continuous, it would be differentiable as well, but it might not be analytic. But it is for sure that if a function is not continuous, then surely it will not be differentiable and surely it will not be analytic, right? So statement and everything, all the concepts are clear to us. We will not puzzle ourselves with the concept, but we need to have a problem solving technique as well. That's why checking the analyticity will become a difficult task. I know that separately they are always analytic, always analytic, always analytic. So instead of checking the analyticity, sir, what I will do is that I will try to make the function discontinuous. If the function is discontinuous, then for sure I will be able to say that it will be not analytic. Is that understandable to you or not? So our target is making the function discontinuous. We are going to study a topic called singularity. Okay, what is the name of topic? Singularity. There also I will say the same thing. The definition of singularity is given by function being not analytic. Here I can show you. We will study the topic singularity. So what is the definition of singularity? Definition of singularity is where the function fails to be analytic. This is the definition. But instead of checking the analyticity, what we will do? We will try to take the function to infinity or undefined. Infinity or undefined. So if our function becomes infinity or undefined, then I would be able to tell that, sir, it is not continuous. And if it is not continuous, then for sure, sir, it will not be analytic. I hope all the points, everything is clear to you. With good amount of patience, we are learning everything. So I hope it is not creating any problem for you. Okay. Not continuous will surely be not differentiable, will surely be not analytic. But if it is something not analytic, then it doesn't mean that it will not be differentiable. It doesn't mean that it will not be continuous as well. Right? Not analytic is not alone enough, but not continuous is alone enough to say not differentiable, not analytic. Right? Now let's get back to the question. Which of the following function is analytic in this region? So where this guy will create the problem? So this guy will create the problem at z equals to 0. Where this guy will create the problem? So this guy will create the problem at z equals to minus 0.9, minus 0.5j. Basically, I am putting the denominator equals to 0, right? Where this guy will create the problem? It will create the problem as at minus 2.5j. And where this guy will create the problem? At z equals to minus 2. You need to check in this domain, no? Now let me know, let's talk about option D. Where will be z equals to minus 2? Z equals to minus 2 means minus 2 plus iota 0. What will be this point? It is a radius of 1. So what will be this point? 1, 0. What will be this point? This point will be 0, 1. What will be this point? So this point will be minus 1, 0. And what will be this point? 0, minus 1. So where will be minus 2? Here will be minus 2. It is lying outside. So problem is at minus 2. The problem is happening at z equals to minus 2, but this z equals to minus 2 is lying outside the circle, outside this disk. That means it is never a problem for us. That means it will be analytic. For sure it will be analytic in the region mod of z less than 1. Did you understand this point? Because z equals to minus 2 is lying outside. What about option A? Z equals to 0. Is it lying inside? Absolutely. Z equals to 0 means it is lying inside the circle. So yes, it is a problem. That means it will not be analytic. The answer is, it is not analytic. It is not analytic in mode of z less than equals to 1. Understandable? If I would have given this region, mode of z minus 2 less than equals to 1. That means center at 2, 0, sir. Center at 2, 0 and radius of 1. center at 2 comma 0, radius of 1. This would have been the region. If this was my region, of operation, then sir, z equals to 0 will be lying outside, then it would have been analytic. But in this domain, mod of z less than 1, z equals to 0 is lying inside the circle. That means here it is not analytic. I hope it is completely understandable to you. What about 2j? Sir, where will be 2j? Sorry, what about minus 2.5j? We are talking about minus 2.5j. What is the meaning of minus 2.5j? Sir, the meaning of minus 2.5j is, it is nothing but 0 plus minus 2.5g. 0 plus minus 2.5g. So x equals to 0 and y equals to minus 2.5. This will be the point, right? This will be your 0 minus 2.5g. Is it lying outside? Absolutely, sir. It is lying outside, no? Because this is 0 comma minus 1. So what is this point? This point is nothing but minus j. What is this point? This point is plus j. So minus 2.5j is lying outside. That means yes, it will be analytic. What about this point? Minus 0.9 minus 0.5j. Sir, by the geometry I cannot tell. Minus 0.5 minus 0.9. Sir, here will be minus 0.9. Sir, where will be minus 0.5j? Sir, it could be here as well. It could be here as well. Sir, by geometry I will not be able to tell. So what method I told you? What method I told you? I told you a method, no? For the point lying inside the circle, for the point z equals to z naught lying inside the circle, what will happen? Mod of z naught would be less than 1 inside the circle. Mod of z naught would be less than 1, and outside the circle, what will happen? Mod of z naught would be greater than 1, right? That means you need to check in place of z what you need to put, z naught. In place of z you need to put z naught, which is minus 0.9 minus 0.5j. This process we have already seen with the complete explanation. So what is the magnitude you will be getting? So the magnitude that I will be getting is 0.9 whole square, that is 0.81 plus 0.25, that would be 1.06, which is surely greater than 1. That means this particular point is lying outside of unity circle. What does that mean? That means, sir, here as well it will be analytic, because this point will be lying somewhere here. Which point? Sir, minus 0.9 minus 0.5j. Minus 0.9 minus 0.5j would be somewhere here. Okay. So by the geometry you will not be able to understand it, but by your concepts you will be able to understand. So in the examination, do you ever need to make this region? Like, will you make this circle? Is it required to make the circle? No. What you can do? Sir, z equals to 0, you directly put z equals to 0 here. Basically, if I need to check the option, what I will do? I will check option A. What I will do? Sir, mod of z is given. No, what is my equation of circle? Equation of circle is mod of z equals to 1, or mod of z equals to 1. This is the equation of circle. So what I will do? Here I will put, in place of z I will put 0. What is the answer I am getting? 0. Is it less than 1? That means it is inside. Option B, mod of z. What is the equation of circle? Mod of z equals to 1 only. In place of z, what I am supposed to put? Minus 0.9 minus 0.5j. Minus 0.9 minus 0.5j. What is the magnitude I am getting? So magnitude that I am getting is this, which is greater than 1. What does that mean? Outside. Next, option C. What is the equation of circle? Mod of z equals to 1. In place of z, what I am supposed to do? In place of z, I am supposed to put minus 2.5j. Minus 2.5j. What you will be getting? What is the magnitude? 2.5. Is it greater than 1? Absolutely. Outside. So in the examination, you will not have to draw the structure. What is the center? What is the radius? Nothing you have to draw. What you need to do? In the examination, simply put the point. No. Z equals to minus 2 you put here. Option D. Z equals to minus 2 you put. What is the equation of the circle? That is the equation of the circle. In place of z, what I am supposed to put? Z equals to minus 2 you put. What is the magnitude you are getting? 2. Is it greater than 1? Yes. What does that mean? Outside. Say yes or no. So that's it. Understandable? So you will not have to make the structure. This is how you can tell. Let's go to the next question. So it will be analytic at B, C, D, but not at A, which is lying inside. Understandable? Let's go to the next question. Now 3 questions we are going to solve. All are related with the transformation. Do you remember the topic which we studied in the basics of complex number? This transformation, omega equals to ln z. This is your f of z. F of z is given as ln z. F of z is given as ln z. Okay. So this time you are given the equation of u, not v. This time you are given the equation of u. That means what is your omega? Omega is u plus iota v. So what is given? U equals to constant. But that means there is a line which is u equals to constant. If you draw omega plane, so in the omega plane what it will look like? This is your u, this is your v. So u equals to constant they are talking about. That means this is your u equals to constant. U equals to constant they are talking about, and it will be extended till minus infinity and plus infinity. So this is your C point, C comma 0. So u equals to constant and v is going from minus infinity to infinity, because if they are not mentioning v, that means v is going from minus infinity to infinity. So this is the line. How this line will be mapped to xy plane? This is what they are asking. How it will be mapped to xy plane? How it will be mapped here? This is what, अरे भाई ये क्या कर रहा हूँ मैं? This is what they are asking. How it will be mapped to xy plane? Understandable? So this question we are supposed to solve. U equals to constant gets mapped in z plane. How? How it is mapped in the z plane? So try doing it. Try doing it on your own. What you will do? Ln z is given, no? So if I put ln x plus iota y, will I be able to separate? Nothing I will be able to do. So in place of x plus iota y, what I will have to put? In place of x plus iota y, I will have to put r e to the power iota theta. Basically, let's just say this is my z. So z is x plus iota y, which can be replaced with r e to the power iota theta. What is r here? R is nothing but under root x square plus y square. Theta is the angle which we are not carrying as of now. So let's put here in place of I am putting r e to the power iota theta. So what you will be getting? So I will be getting ln r plus ln e to the power iota theta. Right? I have simply applied ln a plus b. So ln e to the power iota theta. Now ln e will become 1. So what I am getting? Ln r plus iota theta. This we have already seen, right? So your u plus iota v is coming out to be ln r plus iota theta. So this is the real part, this is the real part, this is the imaginary part, this is the imaginary part. I need to only compare the real part, which will be ln r. Why I need to compare only the real part? Because our equation for real part is given. No, v is going from minus infinity to infinity, but real part is equals to constant. So u equals to constant is given. No, u equals to constant. That means it would be equals to ln r. So what you can see? C equals to ln r, that means r will be equals to e to the power c, which is also a constant only. E to the power c will be a constant only. So r equals to constant. What is r? R is nothing but, sir, under root x square plus y square. That will be equals to constant. What does that mean? That means x square plus y square equals to constant square. So what you are getting? X square plus y square equals to constant square will also be another constant. So what is this? This is your circle only. This is your circle only. So what it will represent? It will represent the circles. But a set of concentric circles they have said. What does that mean? That simply means like you can compare this imaginary part as well. What you are getting? V equals to theta, right? And v is going from minus infinity to infinity. That means v can take any value. V can take any value. This is what they are saying. So when you represent your z, z is x plus iota y, you say your r is under root x square plus y square. Now here, if I assume this point to be x comma y, what will be my angle? So tan theta would be y by x. This length will be y and this length will be x. So what will be your theta? Theta will be tan inverse y by x. Are you able to understand this point? So how I can write down my theta? My theta would be tan inverse y by x. Tan inverse y by x. This will be my theta. Okay. So v is going from minus infinity to infinity. And v is coming out to be equals to theta only. Imaginary part if I compare. That means tan inverse y by x is going from minus infinity to infinity only. Right? What is the value of tan inverse? Tan inverse y by x is going from minus infinity to infinity. Okay. This is iota theta, v equals to theta. So what conclusion you can make? So you will get infinity at pi by 2. and minus infinity at minus pi by 2. Yes or no? What is tan pi by 2? Tan pi by 2 is infinity only. That means y by x is going from minus pi by 2 to pi by 2. So we cannot make any conclusion from here. So it is a irrelevant information. It doesn't make any sense. Irrelevant information. So it is of no use here. Just from here you can understand, no, that x square plus y square equals to constant. This is what we are getting. So value of constant could be anything. Let's remove this. It is irrelevant information. Okay. What we are getting, x square plus y square equals to constant. So constant could be anything. No, constant could be 1 as well, it could be 2 as well, it could be 3 as well, it could be 4 as well, it could be 5 as well. So from here only we are able to understand that sir, x square plus y square equals to constant. Let's just say constant is 1, then this is the circle. If constant is 0.5, then this will be the circle. If constant is 2, then this will be the circle. Right? What I am saying is that this is constant equals to 2. This is constant equals to 1. This is constant equals to 0.5. So different circles we are getting, no? In that manner, different circles we will keep on getting. So what is the meaning? This is the meaning of concentric circles, set of concentric circles. Understandable? Okay, well and good. Yeah. So this is how we are supposed to solve. Next questions. So here don't go blindly that sir, you told us a method, no, that you convert omega in terms of function of z is given. You need to convert z in terms of omega. But here information about x and y would be given, no? But now the information about u is given. So from omega plane to z plane you are going. This is the opposite process. It is a opposite process, right? So we are following the opposite process here. So this is not required. So somehow you compare and your job would be done. Try solving this question. Omega equals to 1 by z. Okay. In z plane, this point A is given. This point A is given. What is the transformation? This is your transformation, that omega equals to 1 by z. This point A is given. You need to map this point in omega plane. How will you map this point in omega plane? What is your z? You let me know what is your z. Z is sir r e to the power iota theta, where r is the length from the origin. Is it less than 1? Because mod of z equals to 1. That means sir, this length would be 1, right? This length would be 1. This length would be 1. That means sir, r is surely less than 1, and surely it will be greater than 0 as well. So it is not a relevant information. R is less than 1. What about theta? Sir, theta is, this is my theta, right? What about theta? Sir, theta is between 0 to pi by 2, right? It will be somewhere between 0 to pi by 2. 0 to pi by 2. Like this angle is between 0 to pi by 2 only. I don't know this angle. This angle will be somewhere between 0 to pi by 2. What will be my omega now? Sir, omega will be 1 by z, which is nothing but 1 by r e to the power iota theta. And I can replace it as 1 by r e to the power minus iota theta. So now I am having new complex number, which is 1 by r e to the power minus iota theta. This is my complex number. This is my complex number. So magnitude of this complex number is, magnitude of this complex number is 1 by r, and the angle is minus theta. So if r is less than 1, then 1 by r will be greater than 1. If r is less than 1, then 1 by r would be greater than 1. That means the magnitude would be greater than 1. And what about the angle? Let's just say this angle was 60 degree. Let's just say this was 60 degree. Now what will be the angle? Angle will become minus 60 degree. If this theta was there, between 0 to pi by 2, then minus theta would be there between minus pi by 2 to 0. Minus theta would be there between minus pi by 2 to 0. Say yes or no? Like theta was less than pi by 2. That means minus theta would be greater than minus pi by 2. And theta was greater than 0, then minus theta would be less than 0. I hope you know this thing. Multiply with negative sign on both of the sides, then this sign will also change. If you multiply with negative sign, then this sign will also change. Right? So what does that mean? That means theta would be about minus theta if we compare. So scenario would be that minus theta would be greater than minus pi by 2 and less than 0. That means your complex number is having a magnitude which is greater than 1. So in omega plane, if I go in omega plane, if I go, so first of all I will make the unity circle. First of all I will make the unity circle. So this will represent the real part of omega. In the examination they will not write down uv. What they will do? They will write down real part of omega and real part and imaginary part of omega. So you know your number would be having a magnitude greater than 1, and the angle between minus pi by 2 to 0 degree. That means it would be somewhere here. Say yes or no. Let's just say if this is my A, then let's talk about it. This is your vector A. What is the length? Length is greater than 1, no, because this is your unity circle. Mod of z equals to 1. This is your unity circle. So this length is surely greater than 1. Yes, sir. And what is the angle? Angle that is made is minus theta. That means angle is also between 0 to minus pi by 2. So sir, it was a simple question that sir, here magnitude was less than 1. So if you just do the reciprocal, then magnitude will become greater than 1. Magnitude will become greater than 1. Along with that, sir, what is the angle? Angle will also become negative, no? So if it was a 60 degree angle, it will become minus 60 degree angle. There you go. So this will be your point A. So 4 options would be given. It is a very, very famous question, especially for EC and electrical students. Very famous question. These kind of questions are asked again and again, that you need to map the point A with the transformation omega equals to 1 by z in the omega plane. So you would know that, sir, I am doing the reciprocal, magnitude will become greater than 1 and the angle will become negative. This will be the point. Very, very, very famous question. In the test series as well, I will frame the question from here. I will not give this transformation, I will make it difficult, but I hope you know that how to map the points. You just need to care about magnitude and the angle. See the magnitude and see the angle and then comment. 4 options would be given, this option would be correct. This cannot be asked in MSQ, right? Sorry, this cannot be asked in NAT type. In the MSQ also it cannot be asked, it has to be asked in MCQ only. So this question will be asked in MCQ and this option would be there, you need to click on this option. Understandable? Let's go to the next question. This is actually a good question, but you should be able to understand. Let a set is given which is z such that mod of z equals to 1. What is the meaning of this sign? Such that. I hope you are studying linear algebra. If you have studied linear algebra from here, then you would know this is such that. Z is such that mod of z equals to 1. It is a set of all the points in the complex plane corresponding to the unity circle. That means we are talking about all the points which are lying on this circle, which are lying on this particular circle. This is what we are talking about. This is your x and this is your y. So all the points are lying on this circle. All the points are lying on this circle. So we are talking about all the points which are lying on this circle. Okay. Now consider a function. Now this function is given which is z dot z multiply with z bar, where z bar denotes the complex conjugate of z. Then f of z maps s to which of the following complex plane? That means your f of z, or you can call it omega, that is z into z bar. That means it is x square plus y square. Z into z bar will be x square plus y square only, no? What this will represent? Z into z bar, mod of z whole square, x square plus y square. What is your omega? Sir, omega is u plus iota v. And what is this? You are getting x square plus y square plus iota 0. Now these are the points. These are the points of set S. So what we are given? We are given that x square plus y square is equals to 1. This is what we are given, that x square plus y square equals to 1. Right? So from here what you are getting? That sir, v equals to 0 and u equals to x square plus y square, which is equals to 1. V equals to 0 and u is x square plus y square, which is equals to 1. That means the value of v is coming out to be 0 and the value of u is coming out to be 1. That's it. That means fixed value it is, no? So in the complex plane, how will you denote them? In our plane, in our omega plane, sir, this will be u and this will be v. Sir, the value of v is fixed, which is 0. Value of u is fixed, which is 1. So value of u has to be 1 and the value of v has to be 0. So this will be the point. So it will be a point 1 comma 0. That's it. Sir, my function was given x square plus y square. So I need to take all the points. I need to take the set of all the points which will satisfy the equation x square plus y square equals to 1. And I need to map it in the omega plane. Omega plane is saying that the value of my real axis is equals to x square plus y square and the value of my imaginary axis is 0. So on the imaginary axis it will be always 0 And now you are saying that x square plus y square has to be equals to 1. That means it will simply represent a point. There you go. Understandable? All good? So this question is also solved. All these are gate PYQ actually. This is a gate PYQ as well. This is also a gate PYQ. This question that we have solved. This was also a gate PYQ only. And this is also a gate PYQ only. Okay. Let's solve the next one. This is a very good question. Okay. This is a very, very good question. Try solving it. If you are able to solve, then it's very good. Like basically what this bilinear transformation is doing. Your f of z is given, that is z minus 1 upon z plus 1. So it will map the inside of the unity circle, inside of the unity circle. So they are talking about inside of the unity circle and they are talking about the outside of the unity circle. That means they are talking about two things, x square plus y square. What is the meaning of unity circle, sir? Meaning of unity circle is, whenever they say unity circle, what is the meaning of unity circle? So unity circle, simple meaning it is having mod of z equals to 1. So whenever they say inside of unity circle, inside of unity circle, inside of unity circle, what is the meaning of inside of unity circle? So the meaning of inside of unity circle is mod of z less than 1. And what is the meaning of outside of unity circle? That is, sir, mod of z greater than 1. What is the meaning of this? The meaning of this is x square plus y square less than 1. And what is the meaning of this? X square plus y square greater than 1. Right? So how they will be mapped in our omega plane? Like inside of the unity circle from z plane, basically they are asking that in the z plane I am having a disk. In the z plane I am having a disk. So in omega plane how it will look like? This is what they are asking. In z plane I am having a disk. In omega plane how it will look like? In z plane I am having a disk. This is the disk I am having. So when you go from z plane to omega plane, how it would look like? This is what they are asking. Under the transformation of omega equals to z minus 1 upon z plus 1, under this transformation. So we have a certain method that you convert omega in terms of z. Sorry, omega as a function of z is already given. You need to convert z in terms of omega. So this is our task. Like they are not asking opposite. No, they have given this region. You are supposed to plot this region into omega plane. So we have a certain method. Omega equals to z minus 1 upon z plus 1. So omega z plus omega equals to z minus 1. So omega plus 1 z minus omega z. So value of z is coming out to be 1 plus omega upon 1 minus omega. Say yes or no. Right? What I have done is that this 1 I have taken this side. So this becomes omega plus z and z minus omega z. So z you take common 1 minus omega. So 1 plus omega upon 1 minus omega. This is the value of z we are getting. Right? Understandable? Now what is your z? Z is nothing but x plus iota y. And what is your omega? 1 plus u plus iota v upon 1 minus u minus 1 minus omega you have to do, no? So 1 minus u minus iota v. Like 1 minus omega, 1 minus u plus iota v. So 1 minus u minus iota v. Now you will start doing the rationalization and all those things. So if you proceed from here, no, it will be difficult calculation. Difficult calculation. You are not using your brain at all, right? Difficult. You are not using your brain at all. If you have find out this particular thing, what is given? We need two kind of region. This region and this region. So what I will do is that I will find out the value of mod of z directly. What is the value of mod of z? So the value of mod of z is 1 plus omega upon 1 minus omega. Right? Now can I separate them? Magnitude of 1 plus omega upon magnitude of 1 minus omega. Like basically they are like two complex number, no? Z1 by Z2. If you are taking the magnitude, then can I do like this? Absolutely you can do like this. Why is that so? Because let's just say Z1 is R1 e to the power iota theta and Z2 is R2 e to the power iota theta. Iota theta 1, iota theta 2. So what will be your Z1 by Z2? I'm talking about Z1 by Z2. So Z1 by Z2 would be coming out to be R1 by R2 e to the power theta 1 minus theta 2. And if you talk about the magnitude, then what will be the magnitude? This will be the magnitude. So it's like R1 by R2. Yes, what is R1? R1 is the magnitude of Z1. What is R2? R2 is the magnitude of Z2. Sir, Z1 by Z2 I was supposed to calculate. Simply I have to wrote down the complex number. Magnitude is coming out to be R1 by R2. Yes, sir. This is what it is representing. So you can separate the magnitude, right? Are you able to understand this point? Let me write down some properties. If you are confused, then simply write down the properties. That if there is mode of Z1, Z2, you can do like this. And if it is mode of Z1 by Z2, you can do like this. What is, sir? This is the scenario. We have seen the discussion, no? You cannot do like this, right? You cannot do like this. We have seen the discussion, no? What we saw? Sir, mode of Z1 plus minus Z2 will be less than or equals to mode of Z1 plus Z2, and sir, it would be greater than or equals to magnitude of mode of Z1 minus mode of Z2. This we have seen, right? Say yes or no. So detailed conclusion and everything we have seen. There wouldn't be a single thing which you are going to miss on PrepFusion. We have made lengthy courses, but we never miss out on anything. When you see in the examination hall, when you get into the examination hall, you will realize that what kind of effort we have put. Not before that. People might be thinking there's so much of lengthy course, this or that. But I look at the February examination, not at the permanent happiness. Okay, I can give you permanent happiness by teaching some method and all, but some trick or technique, but it doesn't work in the longer run. We need to think about February, not about some test series or some temporary happiness, right? So always look for bigger things in the life. Don't do anything for the small dopamine. Let's get back to the concept. So what we need to do, we need to talk about mode of Z less than 1. Let's first talk about mode of Z less than 1. Mode of Z less than 1. So what is the meaning of mode of Z less than 1? That would be magnitude of 1 plus omega divided by magnitude of 1 minus omega less than 1. Sir, it is a positive value. This is also a positive value, so I can take this side. So what I am getting? Magnitude of 1 plus omega is less than magnitude of 1 minus omega. What is your omega? Omega is nothing but u plus iota v. So I will put u plus iota v here. So from here what I am getting? 1 plus u plus iota v should be less than 1 minus u minus iota v. Right? In place of omega, what you are supposed to put? U plus iota v. So it will become 1 minus u minus iota v. What you are getting? Under root 1 plus u square plus v square would be less than under root 1 minus u square plus v square. Simply I am taking the magnitude. This is 1 plus u plus iota minus v. So a square plus b square. Say yes or no. Can I cancel out under root to under root? Yes, sir, both are positive values. No, surely I can cancel out. Under root 5 is greater than under root 3. Then if you cancel out, then 5 would be greater than 3. No, there is no doubt about it. Right? So 1 square plus u square plus 2u plus v square is less than 1 square plus u square minus 2u plus v square. So from here 1 getting cancelled out, u getting cancelled out, 4u, yeah, is 4 and u together is becoming difficult. 4u should be less than 0. That means u being less than 0. So what we are getting? U being less than 0. That means, sir, mode of Z less than 1. Mode of Z less than 1 is equated to u being less than 0. So what do you think what will happen when mode of Z is greater than 1? That would be u being greater than 0. So this particular region in UV plane has been plotted u being less than 0. U being less than 0. This particular region has been plotted u being less than 0. That means this region where u is less than 0. This region. So what they are saying? It will map the inside of the unit circle in the Z plane to the left half of omega plane. Yes. And it will map the outside of the unit circle in the Z plane to the right half of omega plane. Yes. Is that understandable or not? What is meaning outside? Outside means this, and it will map the outside of the unity circle in the z plane to the right half of omega plane. Yes sir, u greater than 0 will become right half of omega plane. This is the right half. This is your right half. No, this is your right half, and this is your left half. So right half, left half. Are you able to understand this point? So mode of z less than 1, mode of z less than 1 has been plotted in the left half of omega plane, and mode of z greater than 1 has been plotted into the right half of omega plane. This question is considered as a question of signal system. It has been asked in EC. It is considered as a question of signal system. In signal system, we actually study bilinear transformation, although it has been excluded from the syllabus now. It has been excluded. But signal system mathematics, some concepts are interrelated. Okay, so this is the interrelated concept. So don't worry about it. It can be asked in engineering mathematics as well. So how will you plot from one plane to the another plane? That you have understood in a great manner. Say yes or no. How will you convert it? This is how you will convert it. Now the task is that, sir, if I go with my conventional method, it is becoming very difficult. Some difficult calculation is taking place. But this will not happen. I will tell you one thing. Okay, always remember, in 1 mark of question, in gate examination, in 1 mark of question, there will never be complex calculation. Never complex calculation. Never ever. I have seen so much of gate paper. We have solved so much of gate PYQs. Never complex calculation you will find out in 1 mark of question. In 2 marks of question, more than 70% of the problem. Okay, 2 marks of question. How many 2 marks of question would come? 35. So out of 35, I would say 25. Out of 35, 25 questions will not have complex calculation. 30% of the question may have complex calculation. But for sure, 1 mark of question will never have complex calculation. If you are doing complex calculation, that means you are missing some point. Like here, you might be missing this point, no? Because like it will not click to 90% of the students. They will go by the conventional method. Here, they will mess up the calculation then. Somehow they will try to interrelate with x square plus y square less than 1. This much process, everything, all these things, everyone would be able to do. Here, people will start struggling. They will struggle here. So this will not click that, sir, z I am able to find out. Let's do mode of z less than 1, mode of z greater than 1. That will not click to a lot of students. If it is clicking, then job done. U less than 0, u greater than 0. Then you will be able to see. If I was a student, and let us say I am stuck here, then I would go to the options. What my options are saying? Options are saying left half of omega plane, right half of omega plane. Then I would start thinking. What I would start thinking? That, sir, they are talking about u less than 0, u greater than 0. That means inequality sign is there, no? U less than 0. I would get to know the answer that either my answer will be u less than 0 or u greater than 0. So this answer I will be able to understand. That it would be u greater than 0 or u less than 0. So with respect to option, I got an idea that I need to make the inequality. If I need to make the inequality, then what inequality I am having? Mode of z less than 1, mode of z greater than 1. Then yes, this is the inequality I am having. So if this is the inequality I am having, then it would click to me that yes, this process I need to follow. Is that understandable? So people always ask me, sir, what is the technique of solving MCQ questions, or what is the technique of problem solving? So all these problem solving and everything I can explain during the lectures. I cannot make a strategy video that this is a strategy, right? When we frame our all India mock test for EC and electrical, so there as well I make the solution of all the question. There also I tell you that in the examination hall how I could have solved it, right? So always problem solving technique matters a lot. But the problem is that people focus only on the problem solving technique. They don't focus on the concept. I have seen some platform will be focusing only on the problem solving technique, that you apply this method, you get the answer. You apply this method, you get the answer. And some would be only concept, that this is the concept, solve the problems on your own. Both of the things are not enough to crack the examination. Always there has to be an equilibrium. That concept you need to study, along with that solve a lot of problems with the problem solving technique as well. If you have the equilibrium, then there is no one who can stop you. Okay, and all these things can be explained during the lecture. And sir, how all these things will start clicking to me? When you solve the questions. Solve as many questions as you can. When you solve the questions, these things will start clicking to you. That yes, in the option this is what they are saying. In my gate attempt, let me tell you one thing. My accuracy was very poor because at that day, I was not at my 100% of mental stability. So my accuracy was very poor. I attempted 64 questions out of 65. And not a single MCQ was wrong. Not a single MCQ was wrong. I attempted all the MCQs correct. One question I left, that was the MCQ only, because there I knew that what's wrong. In that question, that was a question of EMFT. Okay, so I have discussed that in EMFT. So there I knew what is wrong. So that's why I did not attempt that question. And believe me, this question was solved by all the coaching institutes wrong. Till this point, they are solving it wrong. All the coaching institute gave the wrong answer for that. And I knew that this answer would be wrong. So whatever the answer that I was getting in the examination hall, the same answer was given by the coaching institutes as well. And it was wrong. I knew that I am wrong. That I knew. So that's why I did not attempt this. I attempted 64 and all the MCQs were correct. Not a single MCQ I matched up. I matched up NET type questions. I matched up MSQ. But one, I remember one MCQ I matched up actually. One MCQ. Yeah, I got, yes. I got minus 0.66. Yes. And that was of mathematics question only. That was mathematics, right? Mathematics question of linear algebra. In the linear algebra chapter, I have told which question I matched up. Actually, that I got correct initially. I spent roughly around 5 to 6 minutes there, that I got correct initially. But in the last 10 seconds, I got it wrong. Yeah, so one question I matched up actually. One MCQ. Although I got it correct, but in the last 10 seconds, I just got it wrong. So that was a brain fade movement from my side. But all other MCQ was correct. Okay. So this is the point that if you have enough practice, no, then you will not mess up the MCQs, because 4 options are given. You can use those 4 options smartly to get the option correct, to get the question correct. Are you able to understand this point? Okay. Yeah. So just some technique, some examination approach I started telling. So whenever you solve the test series, right? Whenever you solve the test series, always solve in a manner that how I will approach in the examination hall. While solving the test series, it should not be a matter of concern that, sir, what is the concept? After the test series, you learn the concept. But when you are in the test series, no, at that time of 3 hours or 45 minutes or 1.5 hours, whatever the time that you are having, and in that time, your temperament should be that how do I get the maximum marks? Because in the examination hall, you will not be saying, I know this concept, that concept. No one will give you the admission based on that you know this concept or that concept. They will see your score. So your target should be, I get the maximum score. But once the test series is done, after that you can see, okay, this was the approach, this is how I could have solved, this is the concept, all these things. Okay. So always maintain an equilibrium. This I always say, that concept and problem solving both should have the equilibrium. It's not that you are going towards concept only. It's not that you are going towards problem solving only. Both should have an equilibrium. Okay. Yeah. So enough gyan, enough strategy. So this particular topic is done. Analyticity. Here we have solved the questions from basics of complex variable as well. Limit, continuity, differentiability, analyticity, and entire function. This topic is done. Our next topic is singularity. What is the meaning of singularity? Singularity is the point where your function is not analytic. And I told you, not analytic will be difficult for us. So what we will do? We will be focusing towards that point which will make our function infinity. Because I know that, sir, separately it is analytic, separately it is analytic, separately it is analytic, separately analytic, separately analytic, and separately this exponential is also analytic. The problem will be created by these denominators. Problem will be created by these guys. Problem will be created by these guys. So problems they are creating, right? So let me know the point where this function will go to infinity. Let me know that point. So that point will be nothing but z equals to 0. Because at z equals to 0, sir, e to the power infinity will be infinity only. So z equals to 0 will create the problem. Here, who will create the problem? Sir, z equals to 1 will create the problem. Here, who will create the problem? Sir, z equals to 2 and minus 1 will create the problem. Simply put, the denominator equals to 0. F of z is numerator by denominator. So what you do? You put the denominator equals to 0. So z equals to 0, here there is no denominator, but here you need to use your brain. Exponential to the power 1 by z. That means z equals to 0 will create the problem. Z equals to 1 will create the problem. Z equals to 2 and minus 1 will create the problem. And here z equals to minus 2 plus j will create the problem. But here power 2 is there, no? Here there was power 1. Here there was power 1. So z equals to 2 only once I wrote down. Z equals to minus 1 only once I wrote down. Here also there was power 1. But here there is power 2. So I will write it down again. Like if I ask you to solve this equation. This is a quadratic equation. No? This is a quadratic equation. Z square plus 4 plus 4z equals to 0. It is a quadratic equation. That means it will have 2 roots. So what all roots would be there? So z equals to minus 2 and z equals to minus 2. Two roots would be there. Both of the roots are same. So similarly, this is a quadratic equation only. If you put this equals to 0, this will be a quadratic equation only, but it will also have two roots, right? So you will write down the same number twice. Minus 2 plus j, twice I am writing down. Now someone would have a doubt here that sir, your f of z was z square minus 1 upon z minus 1 would be equals to z plus 1 upon z minus 1, a square minus b square divided by z minus 1. So sir, I will cancel this. That would be equals to z plus 1. So sir, here what I can see that sir, z equals to 1 is not a problem for me, because at z equals to 1, f of 1 I am getting 2. If you are saying this thing, that means your concept of limits are not clear. You might not have studied from here, or from wherever you have studied, your concepts are not clear if you are saying this particular thing. If you have studied from here, then you know where you are wrong. Whenever you are cancelling out, whenever you cancel, what you will put here? Z should not be equals to 1, because at z equals to 1, like someone would say that sir, f of 1 should be equals to 2. No, limit z tending to 1, f of z is equals to 2. This is correct, but f of 1, what is f of 1? At exact z equals to 1, at exact z equals to 1, you are getting 1 minus 1, that is 0, divided by 0, which is undefined. So yes, z equals to 1 is a problem. If you are saying that sir, this will get cancelled out, then whenever you are cancelling, you are putting that z should not be equals to 1. So this expression that you are getting z plus 1, that is applicable when your z is not equals to 1. When z equals to 1, then it is not applicable. When z equals to 1, directly you can see that sir, I am getting 0 by 0 undefined form. So this complete discussion we have done when we studied limits. So your concept of limits are not clear if you are saying this particular thing. Okay, so this is known as what kind of singularity? This is known as removable singularity. We will discuss that when we study the types. So singularity has two types: isolated and non-isolated. Isolated and non-isolated. Now isolated will also have four types that we will discuss, but first let's talk about isolated singularity and non-isolated singularity. So let's see the difference between them. So we will read the theory later on, but let's find out the singularity of this function. What all are the singular points are there? Sir, denominator, you need to make the function tending to infinity. So put the denominator equals to 0. You know that sir, singularities are coming z equals to 1, z equals to 3, z equals to 1 plus j and 1 plus j again, because power 2 is there. So these are the four singular points. This will be your real part and this will be your imaginary part. So here only real part is there, that means this is your z equals to 1, this is your z equals to 3, z equals to 1 plus j, z equals to 1 plus j and z equals to 1 plus j. Look here, I made cross two times. If you noticed, 1 plus j and another cross I have made. That means I am telling that here there are two times singularity. 1 plus j is coming two times. So this point will be 1 plus j. Real part is 1, imaginary part is j. So 1 plus j. So these are the singularities, right? Now if I go to z equals to 3 and I ask him, near to you, near to z equals to 3, do you find any other singularity? He will say, sir, near to me, that means nearby circle. In the nearby circle, sir, I don't find any singularity. I am alone here. If I go to z equals to 1, I ask you, in the nearby circle, do you find any other singularity? He will say, no, sir, I am alone here. If I go to 1 plus j, I ask him that, do you find any singularity in the nearby circle? He will say, no, sir, I am alone. So all three guys, z equals to 3, z equals to 1, 1 plus j, all three guys are saying that, sir, near to my circle, nearby, there is no other singularity, we are alone. So all these three are known as isolated singularity. Isolated singularity. Is that understandable to you or not? 1, 3, 1 plus j. All three are known as isolated singularities, because nearby them there is no other singularity present. So a singularity is called an isolated singularity if there exists a neighborhood around the singular point in which there is no other singularity. In other words, it is the only singular point in a small region around it. You would have understood. This is the meaning of isolated singularity. What is the meaning of non-isolated singularity? We will read the definition later on, but first let's see where is the problem. This denominator being 0 will create the problem, no? Basically, the singularity will be when sine of 1 by z equals to 0. When it would be 0? When 1 by z equals to n pi. Right? Basically, when your Z is 1 by n pi. What is the meaning of Z being 1 by n pi? Let's put n equals to 1. If I put n equals to 1, that means when Z is 1 by pi, when Z is 1 by pi, it will become sin pi is 0, 1 by 0 is infinity. Let's put n equals to 2, 1 by 2 pi. Put n equals to 3, 1 by 3 pi. In the same manner, you can put n equals to minus 1 as well. Right? You can put n equals to minus 2 as well. N equals to minus 3 as well. In that manner, all these things. N belonging to integer. Right? So at all these points, there is problem. Why there is problem? Because sir, this will become 0. The sinusoid will become 0, 1 by 0 is infinity. So where are the problems? Let's plot the problems. U plus U V. So let's talk about these guys. So first problem came at 1 by pi. Because it is only real, no? There is no imaginary part. So first problem came at 1 by pi. Let's just say this point is 1 by pi. Then second problem came at 1 by 2 pi. So this much length is 1 by pi. This much length is 1 by pi. So where will be 1 by 2 pi? Sir, 1 by 2 pi will be somewhere near. Somewhere here. The next problem came at 1 by 3 pi. Where will be 1 by 3 pi? This will be your 1 by 3 pi. Next problem will come at 1 by 4 pi. 1 by 4 pi will be here. N value could be 1000 as well, no? So where will be 1 by 1000 pi? 1 by 1000 pi will be somewhere here. N could be 1 lakh as well. Where will be 1 by 1 lakh pi? 1 lakh pi would be here. N could be 1 crore as well. Where will be 1 by 1 crore pi? That would be here. N could be infinity as well. If n is tending to infinity, then what will be Z? Z will be 0. So Z will be here. Z equals to 0 will be this point. Now if I go to this guy, I ask him, near to you, is there any other singularity? He will say no. Near to you, is there any singularity? He will say no. Near to you, is there any singularity? He will say no. Near to you, is there any singularity? He will say no. What about 1000 pi? 1 by 1000 pi. He will also say, sir, near to me, there is no other singularity. What I mean to say is that I will add a page. And what your 1000, 1 by 1000 pi will say. Let's say this is your 1 by 1000 pi. 1 by 1000 pi. If I zoom in, I am zooming in here. Okay. I am zooming in here. I am zooming in. Here I am zooming in. So if I zoom in, then what I would see? I would see that, sir, this is your, if I zoom in, then I would see that, sir, this is your 1 by 1000 pi. The next would be 1 by 1001 pi. So if I go to this guy, he will also say, I don't have any other singularity. He will also say, I don't have any other singularity. Same goes with 1 by 1 crore as well. Let us say 1 by 10 to the power 7. What is the meaning of 10 to the power 7? 0 times. Sorry, 7 times. 7 times. I am being Ravi Kumar. Home from work. Do you know about Ravi Kumar? We will talk about them. We will talk about them in some session, in some live session. Where do we time pass? Okay, but not today. Yeah. So 1 by 10 to the power 7 pi. 10 to the power 7 pi means 7 times. 7 times. मैं तो यहाँ 1 घंटे से बोल रहा हूँ ना, तब ये जवान फिसल सकती है. वो तो 2 स्टेटमेंट बोलते हैं, उसमें जवान फिसल जाती है. होम फ्रॉम वर्क. Right? I am speaking here for 1 hour. So my tongue can slip. Right? But if you are speaking only 2 statements, how your tongue is slipping? He is cute. So he will also say that nearby me, there is no other guy. But Z equals to 0. What Z equals to 0 will say? So just nearby me, there is a guy which is 1 by 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 pi. So just near to me, sir, I don't get any space. There will be a lot of other guys will also be present. A lot of other guys would also be present. So what I mean to say is that all these points, they are isolated singularity only. They are isolated singularity only. They are isolated singularity only. They are isolated. They are isolated singularity only because they are saying that near to me there is no other singularity. They are also isolated only. They are also isolated only. They are isolated only. But this guy Z equals to 0, he will say I am non-isolated. Non-isolated singularity. Is that understandable to you or not? So what is the meaning of non-isolated singularity? A singularity is known as non-isolated singularity if every neighborhood of the singular point contains at least one other singularity. In other words, there is no neighborhood around the singular point which is free from other singularities. That means around z equals to 0, he will say that, sir, around me there will be some 1 upon 0.0000000 pi would also be present. That means around me I am not alone, there is one other singularity is also present. In your examination, you will never do the discussion of non-isolated singularity. You will always do the discussion of isolated singularities only. Is that clear to you? In your examination, we will never do the discussion of a non-isolated singularity. We will always do the discussion of isolated singularities only. They will frame a question in a manner that your singularity is isolated singularity only. That's why you would see that here there is no type, nothing written here. But here there are 4 types. So we will discuss that. They are very simple. But you understood one thing, that in our examination, this will never be a matter of concern for me. Understandable? Okay then. So now we will talk about, first we will talk about simple pole, then we will talk about multiple pole, then we will talk about removable singularity, then we will talk about essential singularity. So I will not say simple pole isolated singularity. I will only say simple pole singularity. I will only say multiple pole singularity. Why is that so? Because we know that we will always talk about isolated singularities only. We are not going to talk about non-isolated singularities. So I will simply say simple pole singularity, multiple pole singularity, removable singularity, essential singularity. Okay. So yes, we will do the discussion for next half hour, for next 30 minutes. We will do the discussion on these types of singularity. Okay. So let me take a break. I will drink some water, then I will come back. We will talk about simple pole, then we will talk about multiple pole, then we will talk about removable, and then we will talk about essential. Okay. And that would be it. And then in the next lecture, we can think of residues. So yeah, just some 20-30 minutes of discussion we need to do, that we will do. Okay, this is actually a complex topic, but what I have done is that I have made a classification. So you will never be facing any problem. So singularity and residue is the most complex topic of complex analysis. Here only people struggle. But we will study in very detail. Okay, first we will study about simple pole, then we will understand what is the difference between simple and multiple pole, then what is removable, then how essential is different from all these guys. Okay, so have some patience. I will come back after drinking some water. Yeah, welcome back. So now we need to discuss the types of singularities. Okay, types of singularity we need to discuss. So first we will discuss about simple pole. So we will read this definition and everything later on, but let's first see the example. Let's take example. Let's just say f of z I am taking as z plus 2 multiply with z minus 3 upon z minus or upon z plus 1. So your function is of a numerator by denominator type, no? Numerator by denominator type. So if you are putting denominator equals to 0, then you would know that, sir, I will get the problem point, that here at z equals to minus 1 I will have a problem. So if I am putting denominator equals to 0, then sir, I am getting a point z equals to minus 1, and at z equals to minus 1, this will be at z equals to minus 1. You know that f of z will be discontinuous, or f of z will be not analytic. You know that, sir, problem point is only z equals to minus 1. So how did you get this point? You got this point by putting the denominator equals to 0. So if you put the denominator equals to 0, then you can get single pole. But other condition is also there. What condition is also there? The other condition is that it should be repeated only once. What I mean to say is that here this guy was repeated twice, no? This particular thing, this guy was repeated twice. 1 plus j was repeated twice. So if I make the diagram here, I would say that z equals to minus 1 is coming only once. It is not repeated twice. Z equals to minus 1 is only coming once. It is not repeated twice. So if it is not repeated twice, no, if it is coming only once, then you would say it is a simple pole, or the other name you can use, that is single pole. So what is the meaning of pole? The meaning of pole is that if you put denominator equals to 0 and your function tends to infinity, if I am putting denominator equals to 0 and my function is tending to infinity, then whatever the point that I get from here, z equals to z naught, this particular point is known as pole. What is the meaning of simple pole? The meaning of simple pole is that it should be a pole of order 1. Pole of order 1 means it should be coming only once. So we have seen these examples, no? These examples we have seen. So here all kind of example I have framed. These are my simple poles actually. These are my simple poles. Now you let me know minus 2 plus j is coming twice, no? So this will be known as multiple pole. Multiple pole singularity. Multiple pole singularity. Multiple pole singularity. Now here sir, z equals to 1 we will also get by putting that denominator equals to 0. So sir, yes, z equals to 1 is a singularity. But sir, you can avoid it, no? If you just cancel it out, then it can be avoidable. So it is known as removable singularity. Removable singularity. Like basically, sir, if you put the denominator equals to 0, you will get the point z equals to 1. But you know one thing that sir, z minus 1 and z minus 1 is being cancelled out. That means it is removable. Right? Because if you find out the limit is finite and it is existing. Although at z equals to 1 there is a problem. That's why it is a singularity. If at z equals to 1 there was no problem, then it would not be known as singularity. So at z equals to 1 there is a problem. That's why it is a singularity. But it is a removable kind of singularity because sir, limit is existing. Now what I do is that I would design my function in a manner that at z equals to 1 I fix some value. If I fix some value at z equals to 1, then I can avoid it. That's why it is known as removable singularity. And the last singularity is essential singularity. This is known as essential. So the singularity which is not removable, which is not simple pole, which is not multiple pole, that is known as essential singularity. This could be the definition. Although other definition is also there, we will study that. So did you understand the difference? You have understood all the types: simple pole, multiple pole, removable and essential. Although we will study them one by one, but in one example only you have understood all the points. If you are putting denominator equals to 0 and you are getting your singularity, here am I putting denominator equals to 0? No. I am not putting denominator equals to 0. No, this is your e to the power 1 by z. It is your numerator and denominator is 1. So I am not finding the singularity by putting this guy equals to 0. I am finding the singularity by this point. Right? So that's why it is not a single pole. That's why it is not a single pole. Are you able to understand this point? Or neither it is multiple pole or nor it is removable singularity. It is your essential singularity. Here what you are doing, you are putting the denominator equals to 0. So if you put denominator equals to 0, then three kind of singularity you can have: simple pole, removable and multiple pole. What is the meaning of simple pole? That sir, if it is coming only once, then it will be simple pole. If it is coming twice or thrice or 4 times or 5 times, then it will be known as multiple pole. What is the meaning of removable? That sir, limit will exist. What you can do is that you can remove this kind of singularity. Although yes, z equals to 1 there is a problem, but it is removable. You can cancel them out, so it is known as removable singularity, and then whatever that is left, that is known as essential singularity. So we will study about them one by one in detail, but I hope you would have understood now what is the meaning of simple pole. So if you read the definition, a singularity at z equals to a is called a simple pole or pole of order 1 if the function can be written in this form: numerator by denominator, numerator by denominator. So now if you put denominator equals to 0, what you are getting? If you put denominator equals to 0, what you will get? Z equals to a. If I put this guy equals to 0, what do I get? Z equals to a. So z equals to a is my point of singularity, and that is known as simple pole singularity. What condition they are giving? They are giving the condition that phi of z should be analytic at z equals to a, and it should not be equals to 0. Why is that? Why is that so? Because you know that sir, at z equals to a, this guy will be 0. And now at z equals to a, if this is also 0, then it will become 0 by 0 form. And if it becomes 0 by 0 form, I can apply the L'Hopital rule. And if I can apply the L'Hopital rule, then it might happen that limit will also exist. And if limit is existing, what does that mean? That means, sir, you can make it removable as well. Right? So it will become a removable type of singularity. That's why this condition is written, that phi of z should be analytic. Along with that, sir, phi of z value at z equals to a should not be 0, because if it is 0, then it will become 0 by 0 form, and that will make our function, what it will make our function? It will make our function indeterminate, and you can apply the L'Hopital rule. So I hope you have understood the meaning of this line. Next, what it is written? In other words, the denominator contains only one factor of z minus a, and the function tends to infinity at z is tending to a. Okay. Like here, if you put z equals to minus 1, if you put in this expression, if you put z tending to minus 1, then what you will get? On the upper side, you will get plus 1. Here you will get minus 4 divided by 0. So minus 4 divided by 0, that would be minus infinity. So there is no point that there is no chances that sir, limit can exist or anything. Simply you know that if limit z tending to minus 1, f of z is coming out to be nothing but minus infinity only. So there is no chance of limit to exist as well. If limit is existing, then it might be removable, but sir, if limit is not existing, then What does that mean? Limit does not exist. So if limit is not existing, no, then sir, there is no chances that it might become a removable singularity. It will be single pole only. And why single pole or why simple pole? Because sir, this pole is occurring only once. Z equals to -1 is occurring only once. I hope it is completely understandable to you. Don't get confused. Complete classification I am giving you. Simple pole, very simple things are denominator should be put towards 0. Whatever the points that I am getting, that should not be repeated twice, thrice or anything. That should be coming only once. Along with that, sir, limit z tending to -1, f of z should be also minus infinity or infinity. Because if the limit is finite, it would become removable singularity. Is that clear to you or not? Completely clear, sir. Absolutely no issue. Say yes or no. Okay. See this example. Numerator by denominator. Numerator by denominator. Put the denominator equals to 0. Put the denominator equals to 0. That means put z plus 1 into z minus 1 into z square plus 3z plus 4 equals to 0. So from here z plus 1 equals to 0. So what is the value? Z equals to -1. Z minus 1 equals to 0. What is the value? Z equals to 1. Z square plus 3z plus 4 equals to 0. What is the value? Z would be minus b plus minus under root b square minus 4ac upon 2a. So that would be -3 plus minus under root 7 iota divided by 2. So what all problem points we are getting? So the points of problem are -1, 1, -3 minus under root 7 iota divided by 2 and -3 plus under root 7 iota divided by 2. All four are different. All four are simple poles. All four guys are different, no? All four are simple poles. If you plot it here in the z plane, if you plot, then how they would look like? Z equals to -1, z equals to -1, z equals to -1, z equals to 1, z equals to 1, z equals to -3 by 2, -3 by 2 minus under root 7 by 2 iota. And this will be your, this is your -3 by 2 minus under root 7 by 2 iota. And this will be your -3 by 2 plus under root 7 by 2 iota. So these are your 4 points. These are your 4 points. All are different. No one is repeated. Along with that, when you put denominator equals to 0, then you are getting it. Along with that, what are the chances of limits? At all these points, is it becoming 0? Is it becoming 0? At z equals to -1, is it becoming 0? No. At z equals to 1, is it becoming 0? No. At this point, is it becoming 0? No. That means it is not removable as well. That means limit z tending to any z0 point you take, if you find out f of z, that is coming out to be infinity only. Or you can say that will come out to be does not exist. So limit will not exist at z equals to z0 here as well. If it is removable, no, then it will get cancelled out only. Right? If it is removable, that will get cancelled out only. So this is known as your simple pole singularity. Very simple discussion. Don't watch it in a quicker manner. Have patience, full concentration, then only you will be able to understand. Otherwise, you will be mugging up the concepts, nothing else. Okay? With the patience, you are able to understand. Let's see the next concept, which is multiple pole. It is ditto similar. Only the point is that here, if you find out the singularity, what you are going to get? Numerator by denominator, again ditto same thing. Numerator by denominator. What you need to do? You need to put a denominator equals to 0. So when you put denominator equals to 0, what value of z you are getting? -1, -1, because here there is power 2. Then +1. And from here what you are getting? Z square plus 3z plus 4. So z square plus 3z plus 4, when we solve, we are getting 2 points which are -3 minus under root 7 iota divided by 2, -3 plus under root 7 iota divided by 2. So we are getting these 5 points. 5 points we are getting, where 2 points are repeated. Z equals to -1 and -1. Twice it is repeated, right? -1, -3 by 2 minus under root 7 by 2 iota, -3 plus under root 7 by 2 iota. अरे भाई यहाँ पे भी उल्टा लिख दिया ना मैंने. This is plus, no? This is minus. This is plus, this is minus. अरे this is plus and this is minus, right? And z equals to 1. This is your z equals to 1. This is your z equals to -1. What about this point? This point is whatever it is, you already know, and this point also you already know. So this particular point or this particular point or this particular point, all these are single pole only. They are single pole, or you can call them simple pole. They are simple pole only. They are simple pole. Like them, because they are repeated only once. They are all simple pole. No, this is also simple pole. This is also simple pole. This is also simple pole, and this is also simple pole. All are simple pole only because they are repeated only once. They are not repeated. This is coming only once. This is coming only once. This guy is also coming once. This guy is being repeated. No, so only this guy is repeated pole, or you can say multiple pole. Repeated pole or multiple pole. Multiple pole, or I can use another name which is repeated pole. Or you can call it pole of order 2. This is your pole of order 2. Pole of order 2. Understandable? Is that clear? Okay. So all these were simple pole. In this example, z equals to 1 was simple pole. Minus 3 minus under root 7 iota by 2 is simple pole. Minus 3 plus under root 7 iota by 2 is simple pole. But minus 1 and minus 1 are repeated poles or multiple poles. Understandable? The same definition is there. Limit should also not exist. The condition is that limit z tending to z naught f of z should be does not exist. Should not be existing, because if the limit is existing, then it will become removable. Now what is the definition of removable? The same thing, sir. Ditto the same thing. I will put the denominator equals to 0. What I will do? Numerator by denominator. Numerator by denominator. So I will put denominator equals to 0. If I put denominator equals to 0, what I am getting? Z square minus 1 z plus 2 whole square should be equals to 0. So it will become z plus 1 into z minus 1 into z plus 2 whole square equals to 0. So from here what you are getting? Z equals to 1 minus 1 minus 2 minus 2. These 4 poles you are getting, right? These 4 poles you are getting. But did you check one thing? At z equals to 1, at z equals to 1, what will happen? Limit z tending to 1, z minus 1 upon, what this could be written as? This could be written as z plus 1 upon z minus 1 z plus 2 whole square. So this and this is getting cancelled out. So limit z tending to 1 is coming out to be finite. This is coming out to be finite. What value we will get? It will be 1 by 2, 1 by 2, 9, 1 by 18. 1 by 18. So what we are getting? We are getting the value to be 1 by 18. Okay, so it is finite. And if it is finite, then there is a problem. Like z equals to 1 is a singularity, absolutely. Is it a singularity? Yeah, absolutely. But it is removable singularity. Okay, it is removable singularity. Are they singularity? Absolutely. They are also singularity. Is this singularity? Absolutely. Let's plot them. If I plot them, then how they will look like? So z equals to minus 2 is repeated twice. There is a singularity at z equals to minus 1. Z equals to minus 2 is repeated twice. This is your z equals to minus 2. This is your z equals to minus 1. And then z equals to 1. Then your z equals to 1. Sir, z equals to 1 was removable because I could know that, sir, at z equals to 1, this guy is becoming 0 only. So it will become 0 by 0 form. That means, yes, there is chances of getting a finite value, right? Limit will exist. So this is known as removable. This singularity will be known as removable. What this singularity will be known as? Z equals to minus 1. What this singularity will be known as? Sir, z equals to minus 1 will be known as simple pole. Is it removable? What I am asking is that limit z tending to minus 1 f of z. What will be the answer? Sir, at minus 1 it will become minus 2. Minus 2 divided by 0. It will become minus 2 divided by 0. That will be minus infinity. That means limit will not exist here. That means, yes, it is a pole. But what kind of pole? It is a simple pole. Because it is repeated only once. It is coming only once. Is it a pole? Yes, sir. Why is that so? Because if you find out limit z tending to minus 2 f of z, what answer you will be getting? If you put minus 2 here, minus 3 by 0, that will also be minus infinity. So is it a pole? Absolutely. But it is a repeated pole. It is not removable. Why it is not removable? Because, sir, limit is not existing. Here limit is existing, that's why it is removable. So it is known as repeated poles. Repeated pole singularity. So simple pole, repeated pole and removable, everything is included here. Is that clear to you or not? Say yes or no. Absolutely, sir, completely clear. Removable, simple pole, repeated pole. Everything is absolutely completely clear. Right? This is your Z plane we have made, no? So this is your x axis and this is your y axis. Z plane we are making. So repeated pole, simple pole, removable pole. You can revise very simple, sir. In the repeated pole, denominator you will put equals to 0, but the poles will be repeated. These poles are being repeated. Along with that, limits should also not exist. They should not be getting cancelled out. Same here as well. This is your single pole. All the poles are repeating only once. This is your removable singularity. What about this guy? Sir, again it is numerator by denominator, no? Numerator by denominator. So, sir, I will find out the point of problem. What is the point of problem? The point of problem is that, sir, dz equals to 0. That means z minus a equals to 0. That means, sir, z minus a equals to 0. That means, sir, z equals to a is the singularity. Yes, it is problem. It is surely a singularity. It is surely a singularity. But what kind of singularity it is? Sir, since you have find out the singularity by putting that denominator equals to 0, then, sir, either it could be removable, one of the possible answers are there, sir. Either it could be removable, or, sir, it would be single pole. It cannot be multiple pole. Why is that so? Or it could be simple pole. It cannot be multiple pole. Why so? Because it is occurring only once. So it cannot be multiple pole for sure. Is it a single pole? So what I need to do is that I need to find out the limit z tending to a sin z minus a upon z minus a. What do I see? I hope you know it, right? What it will become? It will become 0 by 0 form. It will become 0 by 0 form. And if it is becoming 0 by 0 form, what does that mean? That means you can apply the L'Hopital rule. If I apply the L'Hopital rule, then upper side will become cos of z minus a, downward side will become 1 only. Then you can put z equals to a here. What answer you are getting? 1 answer you are getting. That means limit is, this is actually equals to 1. What does that mean? Limit is finite. So if limit is existing, that means it is not a single pole, it is a removable pole. Okay, removable pole I should not say, I should say it is a removable singularity. So yes, here z equals to a, if I plot it, z equals to a. It could be a positive number, it could be a negative number, I don't know. So here I am plotting z equals to a. So it is a removable singularity. Removable singularity. Okay. Yeah, so next we will study about essential singularity, but let me take a break. So one call is coming. Yeah, sorry for the interruption. So now we need to study about essential singularity. The definition is written. The singularity which is not removable, which is not a pole, then it is known as essential, but it is not a good explanation. I will tell you the exact definition here. Okay. So if you see this function e to the power 1 by z, you already know that, sir, there is a problem at z equals to 0. You already know there is a problem at z equals to 0, because, sir, if I put z equals to 0 here, it will become e to the power infinity. So yes, there is a problem at z equals to 0, sir, there is a problem for sure. So this is by your observation you have seen. So in the essential singularity, whatever the examples that you are going to see, no, for those examples you can find the expansion. Can you expand this function? Can you expand this function? Absolutely, sir. I know the expansion of e to the power x, that is 1 plus x square y 2 factorial and so on. So what will be the expansion of e to the power 1 by z? That would be 1 plus 1 by z plus 1 by z whole square divided by 2 factorial. That means I can multiply with 1 by 2 factorial plus 1 by z to the power 3 divided by 3 factorial and so on. So this is the expression that we are getting. Now in that expression, let me simplify it. It is 1 by z plus it is 1 by 2z square plus 1 by 6z cube and so on, e to the power 1 by z. So what this will show? This will show that, sir, at z equals to 0 there is a problem. If you put z equals to 0 here, it will become 1 by infinity, 1 by infinity, 1 by infinity. So from here you get to know that z equals to 0 is a problem, right? Now, sir, why it is known as essential singularity? Someone would say that, sir, if I see from here, it is a single pole. If I see from here, sir, it feels like a multiple pole. This feels like a multiple pole. So exact definition is that your z equals to z naught will be known as essential singularity. It will be known as essential singularity if in the expansion of f of z, in the expansion in the expansion of f of z, you will do the expansion of f of z. There you find out that power of 1 upon z minus z naught. Power of 1 upon z minus z naught. Here I am saying z equals to 0 is the singularity. That means I need to see the power of 1 upon z minus 0. The power of this particular function, is it tending to infinity or not? So here you see, sir, 1 by z plus 1 by 2z square plus 1 by 6z cube, then it will become 1 by 24 z to the power 4 and so on. Then sir, similarly it will come out to be 1 by z to the power infinity. No, because it will be extended till infinity. So 1 by z to the power infinity, and here also there will be some factor. Some factor would be there that I don't know. So you know that, sir, 1 by z will be extended, this power will be extended till infinity. Right? That means z equals to 0 will be known as essential pole. Is that understandable to you or not? Essential pole, I should not say essential pole, I should say essential singularity. Essential singularity. Is that understandable or not? Let me repeat it again. That, sir, I am observing one thing, that, sir, z equals to z naught could be my singularity point. Z equals to z naught could be my singularity point. So what I did was I expanded the function. When I expanded the function, in the expansion I found out that, sir, z minus, if you are doing the expansion, no, if you are doing the expansion, that means you are actually finding the essential singularity only, because you know that, sir, expansion will be till infinity only. That means 1 by z minus z naught to the power infinity surely you will get. Say yes or no. So this factor is very important for essential singularity. Which factor? 1 by z minus z naught. If z equals to z naught, this line is very important. This factor is also very important. 1 by z minus z naught is very important. What is the maximum power of 1 by z minus z naught? So the maximum power of 1 by z minus z naught is coming out to infinity. That means yes, it is essential singularity. If it is simple pole, or if it is multiple pole, or if it is removable, then you will not have to do the expansion. You will be very easily, you will be able to find out them. But if you are doing the expansion, that means you are talking about essential singularity only. Is that clear to you or not? Completely clear. Take this example. F of z equals to sine 1 by z minus 2. If you look at this function, then you don't feel like there is a problem. Someone would say that, sir, z equals to 2 is a problem. Why z equals to 2 is a problem? It will become sine infinity. No, at z equals to 2 it will become sine infinity. So sine infinity will be some value between minus 1 to 1. Some value between minus 1 to 1. So it is not tending towards infinity. No, as of now it doesn't feel like a problem. But when you do the expansion, when you do the expansion of this function, what you will get? What is the expansion of sin x? That is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial and so on. So if you do the expansion, it will become 1 upon z minus 2 minus 1 upon z minus 2 whole cube multiply with 1 by 3 factorial plus 1 upon z minus 2 to the power 5 multiply with 1 by 5 factorial and so on. And in this expression, what do you see? You see that, sir, if z minus 2 goes to 0, that means if your z equals to 2, if you get z equals to 2, then this expression will become infinity, this will also become infinity, this will also become infinity, and it will create a problem. That means, yes, sir, it is a singularity. Now, what kind of singularity it is? So, sir, if I see the power of 1 upon z minus z naught, which is 2, if I see the power of this guy, what is the power of this guy? Here, sir, in the expansion, I know that the power of this guy will be going towards infinity only. Eventually, the power will be infinity. So, yes, sir, power of this particular guy is coming out to be infinity. What does that mean? This will be an essential singularity. So, if you are doing the expansion, then surely you are going towards essential singularity only. Is that understandable to you or not? All the 4 types are, sir, completely understandable. I will again revise it, then only I will go to the next lecture. Look, if this platform means something to you, okay, if I mean something to you, you will not watch this lecture of residue without revising this lecture again. From where onwards you need to revise? From singularity onwards you need to revise. Okay, there is a reason why I am keeping singularity and residue separately. First you revise singularity, again and again people get confused between isolated, non-isolated, everything gets mashed up then when we come to this particular topic. But this is the task that I have taken, that I will make sure that you never struggle in this particular topic, which is singularity. If you don't understand singularity, no, then you will not be able to understand complex integration. Because if you complete complex integration is based on singularity only. Okay, complete. Your 100% of the question of complex integration will be solved by singularity, and some question will be based on vector calculus. I hope you remember vector calculus. So vector calculus plus singularity, job done. So in the next lecture, we will study about residue. So after residue, no, you will be able to solve all the PYQs without even studying complex integration. Everything you will be able to solve. So that we will see. But let's revise from the singularity. Isolated, non-isolated, sir. Isolated nearby region, no one is there. Non-isolated, sir. In the nearby region, I will find something. They are isolated only, but sir, z equals to 0 will be non-isolated. Isolated is of 4 types. Simple pole. Simple pole means, sir, denominator equals to 0. I will get the points. But limit should not also not exist. Along with that, it should be a simple pole. That means it should not be repeated. It should come only once. It should come only once. Along with that, limit should also not be existing. That means you are not able to cancel it out. What do you mean by multiple pole? The same as single pole. It's just that singularity is repeated now. The point is repeated. So it is known as multiple pole. These are single pole only. Only -1 is multiple pole. What about removable, sir? Again, denominator equals to 0. Same process, sir. But the point is that it is removable. That means limit would exist. You can cancel them out. Here also it is like cancelling out only. You would know that, sir, at z equals to a, it will give you a finite value, that is 1. So it is like cancelling out only. So removable, single pole, multiple pole, everything we have studied. Then, sir, essential. Essential, sir, in this we will not follow that process numerator by denominator putting denominator equals to 0. Here we will do the expansion. Here I am getting exponential, then I can get sinusoid, I can get cosinusoid. So what I will do is that I will take the help of expansion. When I expand it, I get to know that, sir, if I put z equals to 0, then there is a problem. Along with that, I need to check one thing, that what is the maximum power of 1 upon z minus z naught. If z equals to z naught is my problem, if I am getting the singularity at z equals to z naught, then I will check the power of 1 upon z minus z naught. If it is tending towards infinity, then yes, it is essential singularity. Here the power is tending towards infinity, that means yes, it is essential singularity. And this factor is very important, very important. When we study about residues, this factor will become very important. 1 upon z minus 2. That means z equals to z naught is your essential singularity. If you are having z equals to z naught as your essential singularity, then the factor of 1 upon z minus 2. So what is the coefficient of 1 upon z minus 2 you are getting here? The coefficient of 1 upon z minus 2 is 1 here, because 1 multiply with 1 upon z minus 2. So coefficient of 1 upon z minus 2 will be known as the residue at z equals to 2. What will be your residue at z equals to 2? That will be equals to 1. Why is that so? Because, sir, coefficient of this guy is 1 only. So that we will see in the next lecture. Residue we will see in the next lecture. So that's why this factor is very important. Okay, coefficient of 1 upon z minus z naught. So when you are having essential singularity, then the coefficient of 1 upon z minus z naught will become your residue. What is your residue? Residue will become, what is the coefficient here? Coefficient is 1. So that's the answer. Okay, understandable? So yeah, that's it. Let's meet in the next lecture. I hope you will be revising everything. Thank you very much. Happy learning.